Good morning, everybody. Oh, I had a small ovation for standing up first thing in the morning. That means congratulations for getting here by 9 o'clock. So I appreciate that. So welcome to the 2023 Rutgers Climate Symposium. So this symposium has been running since 2006. This is not a new event, but we're using this event to mark an occasion where we're rolling out and welcoming sort of the new next incarnation of Climate and Energy Scholarship at Rutgers, with the Rutgers Climate and Energy Institute. Yay. So this is sort of a special initiative for us in this year, and the range of speakers you're going to see today represent the 4 areas at which the Rutgers Climate and Energy Institute is going to focus. And so I'm very excited about the folks who are here today. So thank you guys for coming, all of you guys. We have one person online, but everybody else is here in person. And we had a great dinner last night and got to know each other. So I really appreciate you being here, and I really appreciate all of you folks coming from around New Jersey and the area to join us today. So please enjoy yourselves, talk to your neighbors, find someone new that you haven't met, because that's part of the purpose of these, is to just connect us. And those connections are very important. So to kick us off this morning, I'm going to have Denise Hien, who's the Vice Provost of Research for Rutgers, New Brunswick. And I'll just acknowledge the fact that Denise was the person who came to us and was like, hey, do you think we can do something bigger and better on climate at Rutgers, New Brunswick? And so her work and her office's work and the support from Chancellor Conway have been key to get us to this point. And hopefully, when we move from this point onward and moving into more action-based things. So thank you very much for all that, and I welcome Denise to come up and get us started this morning.
Thank you so much, Julie, and good morning, everyone, and welcome to Rutgers, New Brunswick's Douglas campus. On behalf of Chancellor Francine Conway, who regrets being unable to join us today, I'd like to acknowledge what an honor it is to join so many faculty, staff, students, deans, and other leaders, our invited speakers and guests, as we welcome this wonderful symposium today. I am Denise Hien, Rutgers, New Brunswick Senior Vice Provost for Research, coming to you all as a social scientist myself, but also as a citizen of our planet, recognizing the importance of this symposium and the work that you are all doing to serve the common good. As you may know, Rutgers, New Brunswick is a world-class powerhouse for research that works across disciplines and addresses some of the world's greatest challenges. And this is one of the reasons we were recently named the number 15 top public university in the nation. In 2021, Chancellor Francine Conway initiated a strategic re-envisioning process that we call our Academic Master Plan, or AMP. And the AMP is our blueprint for the future of Rutgers, New Brunswick, and has identified 4 pillars of excellence, one of which is innovative research. The university at its highest level out of the president's office has also initiated an Office of Climate Action led by Bob Kopp and Kevin Lyons to address our university's carbon footprint and how we can reach the Paris Agreement by 2050. So that activity is also happening here. But my office is implementing the innovative research pillar with a set of bold and ambitious new initiatives that we have been unveiling over the course of this academic year. And one of those has been the Chancellor Challenge, which is a plan to invest $15 million over the next 5 years to create and support the interdisciplinary development of interdisciplinary scholarly communities across our multiple academic units that have focused with our themes of climate change and renewable energy, and sustainability, data science and artificial intelligence, and other important issues. So we've launched a series of institution-wide task forces to help us move forward in this effort. And as you all know, very recently we announced the launch of the newly formed Rutgers Climate and Energy Institute, which incorporates and expands on the activities of the Rutgers Climate Institute, the Rutgers Energy Institute, and the Earth, Oceans, and Atmospheric Sciences, or EOAS, Institute. So this new unified home for climate change and energy research will bring us to the next level in producing the knowledge needed for a resilient, equitable, and sustainable climate future. The Rutgers Climate and Energy Institute is now identified as one of our New Brunswick Chancellor Office signature institutes. And the faculty who came together under Julie's leadership to propose this new institute articulated the challenge of climate change scholarship. And I will say it's a very politically difficult to sort of take people from all disciplines and many different schools. We all have our own affiliations to our own entities, and this task force set a model for our other task forces, really, in working together and being willing to kind of, think outside the box and take the resources that were already, here, but to think creatively about how to bring them all together. And I will say that many of our deans, and I just want to specifically acknowledge Dean Laura Lawson, was instrumental in supporting the faculty. But in terms of their vision, they noted that Earth's climate reflects a complex interplay between the atmosphere, ecosystems, oceans, human activity, and the solid Earth. Scholarship and education within each of these areas have developed largely within siloed disciplinary boundaries, albeit with some notable exceptions that have served as potent examples of interdisciplinary scholarship at Rutgers and beyond. But recognition that human-generated greenhouse gas emissions have increased to the extent that the climate is fundamentally shifting in new and largely unknown states has served as a sobering yet catalyzing moment across these disciplines, and really, as a citizen of the world across all of our experiences. And the need still to provide a scientific understanding of Earth's dynamic climate future and to what extent this future will transform Earth's ecological, social, and economic systems sit at the forefront of each discipline today. So in their proposal, the faculty aptly noted that it is only through an all-hands-on-deck approach that climate change scholars can provide the deep scientific understanding, improved predictive capacity, and meaningful responses and solutions needed to meet the challenge of climate change. Physical and life scientists unravel the complex interrelationships among Earth's physical, geochemical, and biological systems. Engineers of all kinds study and develop technologies to give us alternate energy sources such as geothermal power, solar power, and biomass energy, and to help us capture and sequester carbon. Social and economic and behavioral scientists, along with scholars in law and policy, seek to understand how Earth's changing climate affects society, policy, and governance. And scholars and practitioners in the arts and humanities raise awareness, foster engagement, and inspire action around climate change. So addressing climate change requires novel combinations of disciplinary approaches that can identify and achieve technological, ecological, social, and policy solutions to slow the rate at which greenhouse gases are emitted into the atmosphere and inspire and guide the responses of society to the current and pending impacts of climate change. So merging together our existing institutes, our climate and energy institutes, and EOAS, the mission of the new Rutgers Climate and Energy Institute aims to contribute to a resilient, equitable, and sustainable climate future by connecting faculty, students, and stakeholders through transformative climate change research, innovation, education, and outreach. So here we are. As Julie mentioned, we've been holding the Climate Symposia since 2006 here at Rutgers, and in the last 10 years have expanded them to include faculty, staff, and students throughout the region. Welcome to all of you who have come today from Delaware to New York, and actually Ottawa, Canada, and Wisconsin, so beyond our local regional area. You are from community colleges, universities, federal and state agencies, public, private, and minority-serving institutions, and many of you are participating online. We could not be more honored to have you. We hope that today's symposium provides you with knowledge, new opportunities, rewarding collaborations as we collectively work to search for solutions in addressing the challenge of climate change here in our region and beyond. Have a wonderful day. Thank you.
Thank you, Denise, and I realized even though Marjorie wrote everything for me, I forgot to introduce myself. So I'm Julie Lockwood. I'm the interim director of the Rutgers Climate and Energy Institute. I'm also a professor in ecology, evolution, and natural resources within the School of Environmental and Biological Sciences. If you've been around Rutgers long enough, you know that you have to put all those things together and you get very good at saying them and you don't, it sounds okay. So we're gonna move now into having our speakers come up one at a time, and I'll introduce people who will introduce them. So these are folks, in this case, who are going to introduce them that are very key to getting us to this point. And in fact, I want to acknowledge all the folks who kind of got us to this point. So there's, we've already recognized the Chancellor's Office, including Denise, but I also want to recognize the people on that task force that we started 2 years ago, a little over 2 years ago now, and trying to get this off the ground and then ending up at Rutgers Climate and Energy Institute. So that includes a couple people who are here, including Tony Broccoli from Environmental Sciences, Robin Lachinko, who is a dean of something at SAS, and also a professor in geography. Debashish Bhattacharya, who's professor in microbiology and School of Environmental and Biological Sciences. Clint Andrews, who's a dean over at Blaustein School of Public Planning. Jim Wright, who's also here, I think. Who's the chair of Earth and Planetary Sciences and School of Arts and Sciences. Jackie Thaw, who's a professor in Mason Gross School of the Arts. And did I miss anybody? Oscar Schofield, who's a professor in Department of Coastal and Marine Sciences in the School of Environmental and Biological Sciences, and also Rachel Swam, who is a professor of human ecology in the School of Environmental and Biological Sciences. So I believe that's the whole task force. We met once a week for 2 years, so I should know them really well, and I do, but sometimes remembering all of them. But it was a very good group to work with. I've often said it was a fantastic group of cats to herd. We got along really well. We shared a mission together. We did not have no turf fights. We were really into trying to make something work here. And so I hope that that translates beyond this, and so I'm very proud of the work we've done. So thank you guys for helping on doing that. I also want to acknowledge the deans who have provided the support, either through supporting the faculty who are participating in the task force or in any other way. In particular, Laura Lawson, who's the executive dean of the School of Environmental and Biological Sciences. Julie Wade, who's the executive dean of the School of Arts and Sciences, Stuart Shapiro from Blaustein, Jason Gary from Mason Gross School of the Arts, and Alberto Catino, who's the dean of the School of Engineering, which reminds me also on the task force was Dunbar Burney, who's a professor in engineering at the School of Engineering. So those schools were key players in this and will continue to be key players in this in terms of keeping us going and recognizing that what we can do together is bigger than what we can do individually. So thank you guys also for all that support. Okay, so the 4 speakers today represent the 4 areas of the Rutgers Climate Energy Institute. So that includes Earth System Science, the human dimensions of climate adaptation, mitigation, and resilience, energy conservation and energy technology, and climate change communication and the environmental humanities. So we're covering a broad space. We're trying to sort of move those together and think about ways that we can talk to each other and collaborate. And we picked our speakers today very much for their history of making that happen. So I think you're going to really enjoy all the speakers today. So we're going to start off on the Earth System Sciences. And so I'm going to ask Tony Broccoli to come up and introduce the first speaker. I also want to take this moment while he's making his way up to explicitly acknowledge that Tony and Robin Lachinko were the directors of the Rutgers Climate Institute, which is one of the antecedent institutes for this Climate Energy Institute. So they championed that and got us really to this point over the last 10 or 20 years. So thank you. Okay, Tony.
Thanks very much, Julie. Good morning, everyone. Nice to see you all here this morning. And I have the distinct pleasure of introducing our first speaker, who is Dr. John Krasting of the Geophysical Fluid Dynamics Laboratory in Princeton. GFDL, as it's more succinctly known, is one of the world's leading climate modeling centers. It's part of the National Oceanic and Atmospheric Administration. And John builds and uses state-of-the-art models for studying past and future climate change. His research has focused on the carbon cycle, oceanic carbon uptake, and sea level rise, which is what he'll be talking to us about today. John has a bachelor's degree in meteorology from Rutgers and a PhD in atmospheric science, also from Rutgers. So in addition to being our speaker today, he's also an alum. He also has a history as an expert communicator outside of the research and science realm. He worked as a TV meteorologist at stations in New York City and Philadelphia and was nominated for an Emmy Award in that capacity. More recently, he was named Oceanic and Atmospheric Research Employee of the Year by the National Oceanic and Atmospheric Administration, the parent agency of GFDL where he works. And today, he's going to be talking to us about some of the mechanisms that are involved in sea level rise. So John, take it away.
Marjorie, can I use this? Okay. Yeah. Am I anchored to the podium, or am I free to walk about a bit? Okay. All right, can you hear me okay? Great. Thanks for that wonderful introduction, Tony. It's really nice to be here. I've been a part of Rutgers since 1999 when I first came here as a freshman, so it's hard to believe all that time has passed. One thing Tony didn't mention is I still lecture here at Rutgers. I'm an adjunct lecturer in the Department of Environmental Sciences, and I'm happy to teach the 101 course in meteorology. And my career, as Tony mentioned, has been a long gravitation from a childhood passion for the weather and thunderstorms through the lens of climate and understanding what's facing our society, to finding my love of the ocean and the ocean's role in climate. And in many ways, what I'm going to talk about today, sea level rise, is at the interface of all those things that I've enjoyed over the last 25 years. And I hope to share a little bit of that with you today. All right, so the title of my talk is Simulating Steric Sea Level Across Space and Time. Steric sea level is the density changes of seawater and how those relate to sea level rise. So as water warms, it expands. That leads to a change in the water column height and sea level rise. There are many other factors of sea level rise which I'll talk about, but focus today is really on that density-driven change. I'll start by presenting a slide for Ocean City, New Jersey. This is a spot that you could probably pick many places up and down the US coastline that share a similar story. This one means a lot to me. A lot of childhood memories going to the boardwalk with my family in Ocean City. And Ocean City was founded in the 1870s by 4 Methodist ministers who wanted it to be a family resort, and they outlawed the sale of alcohol in 1870 when the town was formed, hence the name a dry resort. So a bit of play on words here. by the Associated Press, amid rising seas, dry resort is wetter than it likes. So we don't have to go very long, maybe a couple of weeks, between coastal flood advisories being issued up and down the Jersey Shore. Just today, the Stevens Institute of Technology is forecasting that the back bays of Ocean City are going to flood in what we call sunny day flooding events. In the 1920s, this is the boardwalk of Ocean City here, there was a massive fire that destroyed the boardwalk, and as a result of rebuilding, the town engineers actually moved the boardwalk closer to the water. So a bit unfortunate in that sense, but it's really not this shore-facing part of Ocean City that floods. It's really the back bay, the western part of Ocean City, where you get removed from the hustle and bustle of the tourism, and this is where a lot of the seasonal, the folks who live year-round in Ocean City live, and they deal with this flooding now almost on a monthly basis. Here's a view of what some of that back bay flooding looks like. This is just last year, October of 2021. When you look at the New York City, Philadelphia region, this is home to 26 million people. The median home price in Ocean City is $1 million. That's the same as Honolulu, Hawaii. There is a tremendous amount of wealth and infrastructure that is being built, not only in Ocean City, but up and down our coastlines. And when you look at the 2019 New Jersey Science and Technical Advisory Panel report led by Rutgers, sunny day flooding events, the kind that we're going to see today in Ocean City, will exceed the current 10-year flood event, which is 3.3 feet along the Jersey Shore. And under a moderate warming scenario, floods like Hurricane Sandy, which is 5 feet above normally dry water, could occur on a yearly basis by 2070. So this is not something that is too far off in the future. Many of us here in the room will live to see and experience what this is. And in many ways, the acceleration of sea level is in response to past warming that has already happened. So Marjorie and Julie, when we were talking about what I was going to talk about today, they stressed try not to be too gloom and doom. So I'm not going to go much further into that. I'm going to talk a little bit more about what I think we can learn from this and how we can go forward. So motivation, I don't have to speak too much to this. I think we're all in agreement that sea level rise is one of the primary impacts of a changing climate that we expect to see. It's this steric or density-driven seawater expansion that is the leading cause of historical sea level rise to date. And climate models, which I build and work with at GFDL, their simulations of ocean heat uptake and redistribution are very crucial tools in understanding the patterns, the projections, and the mechanisms of how the ocean responds to this heat and in turn sea level rise. There are a number of different processes that drive sea level rise. There are interactions with the atmosphere and ocean in terms of heat and freshwater fluxes. The ocean circulation responds in response to that forcing from the surface. We have another big player is the melting of ice shelves and ice sheets. We also have the melt from glaciers on land and changes to the hydrological cycle, the precipitation, evaporation, and runoff that we see in the interchange with different components of the Earth's system. So the sea level rise that we experience is an amalgamation of all those different forcings. So it's truly an integrated effect and response of the ocean to the climate change signal that we are imparting on the ocean. And there is no model to date that incorporates all of these different processes at a dynamical level. We're still, as a science, a ways away from getting to the point where we have a truly comprehensive numerical model that is able to simulate all of these different processes directly. So the most recent IPCC assessment report, some statistics about the breakdown of where the sea level rise is coming from. So this thermal expansion, or steric sea level, accounts for about 50% of the observed rise since 1971. We see that over here. The other half is approximately coming from a combination of glacial melt and ice sheet loss, and about 10% is coming from changes in our land water storage. So that's what's happening now, but going into the future, there's tremendous uncertainty about where we are going. The likely global sea level projections are about 0.28 to 1 meter by 2100. That's a tremendous range. And that uncertainty is coming primarily from our inability to understand what might happen with the Antarctic and Greenland ice sheets. These are tremendous resources, reservoirs of fresh water on land, and the more catastrophic scenarios of sea level rise, even up to as much as 4 meters by 2100, are dependent on the ultimate fate of the ice sheets and how much meltwater perturbation we'll see from that. And we simply don't have well-constrained projections of that yet. It's important to note that going from IPCC assessment report to assessment report, they're produced about every 7 years. There's generally consistency among those, although there's a minor uptick in the most recent projections. AR6 are modestly higher than AR5. On the left is the change in the global energy inventory of the Earth system. The blue colors represent the ocean at different depth horizons. So the lighter blue is 0 to 700 meters. That's what we think about as the very upper ocean. 700 to 2,000, that gets you about halfway down, most of it. And then the abyssal ocean in the deep blue. And then the other components, the ice, the land, and the atmosphere are on here as well. And what you see is that majority of the excess energy being generated as a result of anthropogenic activity is being shunted into the ocean, and in particular, the upper ocean. The vast majority of that heat is ending up above 2,000 meters. And that corresponds very well with where we see the contributions to the global sea level budget over the last 30 years. About half of that is coming from the heat content change in the upper 2,000 meters, and the other half is coming from this meltwater perturbation that I also mentioned earlier. So why is NOAA interested in understanding this? Well, this maps into a number of our key strategic plan activities. It's important that we understand sea level rise from a climate adaptation and mitigation perspective. We see ourselves as being in a position to inform society about what the projections of sea level rise are. We see ourselves in a stewardship capacity in terms of resilient coastal communities and economies, making sure that the blue economy, all of those population densities that live along the coastline are prepared for sea level and understand what could change. And then coastal ecosystems play a vital role in terms of tourism, the health of the overall Earth system, and tourism as well. So this is a very important part of why NOAA is interested in sea level as part of its mission. I was pleased to be part of a recent 2022 interagency report on sea level rise, bringing together folks from NOAA, NASA, EPA, USGS, and FEMA, and Homeland Security, looking at the updated best guess projections for where sea level is going for the United States over the next century. Some highlights from this report: over the next 30 years along the US East Coast, we expect sea level to rise about 10 to 12 inches. That is the same rate that we've seen over the last century. So the rate of sea level rise is increasing. As much as we've seen over the last 100 years expected to happen in the next 30 years. More flooding. Today's moderate events will occur at about a 10 times more frequency. Emissions matter in terms of what we can do about this. If the interagency report concludes that if we are able to curb greenhouse gas emissions, we could prevent up to 5 feet of additional sea level rise along the US East Coast by 2100. And the report calls for continued tracking and observations of the coastal environment. So our sustaining and expanding that monitoring is an important part. So now we'll talk a little bit more into the science of the Steric sea level changes. We mostly think of this as happening on very long time scales. I'm talking out to 2100, this thermal expansion piece. But we actually see that the Steric change, this density-driven change, can actually play a role in understanding decadal changes in sea level, as well as even down to the annual and sea level. And we're using GFDL's ocean and climate models to understand the Steric changes along all these different timescales. We have a number of models in our toolkit to do that. These are our family of most recent generation coupled climate models at GFDL, the 4th generation models. We have a CM4 model, which features a higher resolution ocean. It has a 1/4 degree grid spacing, or a 25-kilometer grid spacing for the global ocean. We have the Earth system model, which has a slightly coarser resolution, so it's a 1/2 degree or 50-kilometer resolution model, but includes an interactive carbon cycle, which allows us to see how carbon flows through the Earth system. And then we have a model, a suite called SPEAR, which has a relatively coarse ocean model, 1 degree, but we can run many ensemble members or different perturbations of that to get a probabilistic view of both near-term changes. This model can be used for seasonal and decadal prediction, as well as a probabilistic view of the long centennial change climate that we are also interested in. We have a number of regional ocean model configurations as well that are being built. These are 3-kilometer domains, particularly along the US coastline, one for the US East Coast, one for the Pacific Northwest, and one for the Gulf of Alaska. So we're using all of these models to try to understand the changes in sea level. This is the global integrated heat content change from, this is an anomaly relative to present day, going back to 1850 for the CM4 model, which is higher resolution, and the ESM4 model, which is intermediate. And the black line is the Levitas et al. Observed estimates of ocean heat content over this period. And it's encouraging that GFDL's models are reproducing that late 20th century increase in sea level rise, heat content change right where it matters the most for sea level rise, in that upper 0 to 700 meters. And these results are consistent with previous studies that compare well with the OBS. Just last week, there was a paper in Nature Communications that came out from the group in University of New South Wales looking at where that heat in the upper 700 meters is going. And a vast majority of that is going into what we call the intermediate and mode waters of the ocean in the upper part. And the reason I mention that is I want to call your attention to some areas of intermediate and mode waters in GFDL's models. So this is the CM4 model, the higher resolution model on the left. This is the maps of the change in Steric sea level in a baseline configuration. This is a pre-industrial control before we have any climate change in it. This is the ESM4 model, which is a 1/2 degree model. And these are cross-sections for different ocean basins. We have the Atlantic, the Pacific Indian, and the global. So in the unforced climate, we see a strong trend in the Steric sea level rise over the South Pacific in the higher resolution model. That corresponds well with this tongue of water that's descending down to about 1,000 meters and moving equatorward as it progresses. This is a signature of Antarctic intermediate water that is absent in the higher resolution model. These are observations from Lynn Talley at Scripps showing contours of potential vorticity. We can use that to highlight where the intermediate water is present. So here it is descending in the Southern Ocean and moving towards the north. Our 1/2 degree model is doing a reasonable job of that, but we're missing that ventilating water mass in our CM4 model. So this is a water mass that provides cool, fresh water to the interiors of the ocean. And without that, we see a result in warming. So that leads to a warming of the water column and steric rise. So there are a couple of points here I want to make. The first is that when we think about sea level rise, there's contributions from anthropogenic heat that we add to the Earth's system, but there's also a redistribution of heat as well, too. So you're rearranging water masses within the ocean, and that locally can provide very significant contributions to sea level rise. So it's important to realize that the heat coming into the ocean is one piece of it. The rearrangement of the ocean circulation is another. The second piece that I want to mention is that we still have some work to do on our models and understanding the pathways of where ocean heat and carbon are being taken up. The atmosphere sets the heat coming into the ocean at a top level, but where that heat ends up ultimately going and how it makes its way through the ocean system is still a very active area of research that we're pursuing. So if you recall, I mentioned that both these models get the global 0 to 700 meter heat content right relative to observations and agree with each other, but they have very different pathways by which that happens. So here's another way of looking at that. Here we're looking at the high resolution model, and this is a breakdown of the budget of heat change over the historical period for the surface heating in blue, the net horizontal convergence or divergence of heat within a basin in orange, and then the net change in that basin in green. And the take-home message from this is that the CM4 and ESM4 models have the same net heat storage change in the Southern Ocean and the Atlantic Oceans, but very different pathways in terms of how much heat they take up. The high resolution takes up about 30% more heat, and that's balanced by about a 30% increase in export from the Southern Ocean to the other basins. So we have more work to do in terms of understanding the pathways by which this heat is redistributed in the ocean. All right, now moving to shorter time scales, we can now look at the changes in steric sea level on decadal time scales. So this figure here shows the breakdown of the heat content observed between the Atlantic Basin and the Pacific Basin. And over the last 30 years, there's been an acceleration in the ocean heat content in the Atlantic. And that's shown out by other studies by Greg Johnson and Sarah Perkey in 2010 doing a regional analysis of heat content changes, highlighting the Atlantic and the Southern Ocean as being increased rates of warming relative to the rest of the ocean. And it's unclear whether or not this is a force signal at this stage or simply variability. There are also other studies by Jerry Meal and Tom Delworth who've looked at the last 10 to 20 years of the historical record and how the heat content has changed in that. And they see a variability across both the tropical Pacific and in the 0 to 300 versus the 300 to 700 meter depth ranges in the ocean. So take-home message here is that there are decadal changes that are happening, some of which are variability, some of which could be forced. If we look at along the US East Coast, there was about 10 years ago a pretty significant anomaly in East Coast sea level where we had a fairly high year. And you can see that relative to the time series of sea level anomalies going back to 1920. It's almost double the range of what we've seen over the last several decades. This has been studied a lot in the past decade, and this has been linked to changes in the Atlantic meridional overturning circulation. This broad-scale circulation which drives warm, salty water from the tropics poleward to the North Atlantic, where it forms dense water and sinks. So that conveyor belt, when that slows down, we tend to see an increase in sea level along the US East Coast. And that's indeed what happened in 2009. If you were to plot all of these transport anomalies, these sea level anomalies against the AMOC transport anomalies, there's a pretty nice correlation here between low AMOC strength and higher sea level, which we saw in 2009. And we capture this in GFDL's models as well. One of the signatures of a warming climate is a slower AMOC. So we've looked at how the Earth system responds to that forcing. And indeed, as we emit carbon emissions at a higher rate, say at the high end of the IPCC scenarios, 25 gigatons carbon per year. Well, I realize these labels should be switched here. I apologize. The lower the carbon emission rates, the more robust the AMOC circulation remains. But when we warm the climate rapidly, we see a more pronounced reduction in the overturning circulation. And that leads to an increase in Atlantic sea level rise relative to the rest of the global ocean. So moving from the decadal timescales now down to the shorter timescales, we see the daily sea level extremes are also linked with changes to this overturning circulation. This is work by Jan Jun Yin at the University of Arizona in collaboration with folks at GFDL, looking at the daily sea level extremes in an unforced climate here in blue and a idealized warming scenario, 1% CO2 simulation in red. And we see that in New York City, there's an increase in the daily sea level anomalies as the climate warms. And the distributions of the daily sea level anomalies are shifted so that we get more in the way of these higher sea level anomalies as the climate warms. So this is a very fascinating paper that links that change in daily sea level extremes both to a change in the mean state related with this overturning circulation and the compounding effects of storms like nor'easters and blocking events along the East Coast. Along the Gulf, it's a slightly different story. There's a sensitivity between the daily wind speed and the daily wind surge height. So in places like New Orleans and Houston along the Gulf of Mexico, where we have hurricane activity, we see an increased sensitivity to storm surges in these regions that will be tied to what the ultimate frequency and intensity of hurricanes is over the coming century. Now finally down to the very short time scales, we can use the Steric changes to help explore changes that are happening on the subannual to monthly timescales. This is work by Dr. Jake Steinberg at GFDL working with me, looking at how Steric anomalies along the Gulf of Mexico and US East Coast are tied to short-term variations. What happens when the ocean warms? So say you pick a region out here in the Gulf of Mexico. When the density changes and the water column rises as a result of that, you create a pressure gradient which drives mass onto the shelf. So this is a way to link the changes in water along the coastal shelf with these Steric anomalies offshore. This is the trend in ocean bottom pressure, or a measure of the mass in the ocean over the period 2008 to 2017. And this is what that trend looks like as a function of depth integrated all along the shelf region below. The gray bars are the observed values, and the orange is a redistribution model fit based on that Steric anomaly offshore. So what this means is that we can use the Steric anomaly or the heat content changes offshore to help understand and predict how the mass will change in being loaded onto the shelf and give us some information about the baseline changes that could be driving monthly to seasonal changes in sea level along the coast. In fact, we're working to implement this in a joint NOAA-NASA project called RISE, which is looking to develop the next generation sea level prediction system along the US coastline, both the east and west. We have 2 pilot locations for Charleston and San Diego that we're looking at. In this curve here, the blue lines here represent the raw output from seasonal prediction models. So this is taking the GFDL model and NCAR's CCSM model. This is forecast skill. The lower the value, the better the forecast. This is again compared to a damped persistence. So that's what you get just by persisting from month to month. So initially, there's quite good skill in the models. The GFDL model does very well up to about 6 months. And then even out to a year, there's still some added benefit of looking at the seasonal forecast models and their sea surface height compared to climatology. The other lines on here, the orange, show the improvements that we try to gain by taking the model output and then doing some statistical downscaling of that as well to do some additional value added in terms of the prediction. So time scale for this is the next 5 years, but this is meant to look at anomalies everywhere from, say, the hourly time ranges, which is going to be useful for shipping and for cargo in the ports, all the way out to the decadal timescales and beyond. You can look at some of this now online, collaboration with Matt Newman at NOAA PSL. Some of GFDL's forecasts are now available on real time through this joint NOAA-NASA RISE prediction website for our 2 pilot locations, and we do plan to expand this a bit as the project matures. So this leads me now to talk a little bit about where we're looking at sea level from an agency perspective. The bipartisan infrastructure law has been a tremendous vehicle by which Congress and then NOAA is able to act on improving sea level representation in our models. GFDL's, if this is seen out for all 5 years, we'll have an investment of $9 million to study and improve our sea level processes. We plan to explore the subseasonal to annual predictability that I just mentioned, using the SPEAR and the regional configurations. For our coupled models, we plan to improve the representation of tides, MOM6, inclusion of Great Lakes, and we're also looking to develop a coupled regional atmosphere-ocean model. This is just a small part of where NOAA would like to go with this. You could think of this as a down payment. There's a much more detailed description of the cross-agency strategy outlined in this white paper, Coastal Inundation at Climate Timescales, that we plan to have available. Well, it is available on our website for you to look at. And when we translate that to what we're doing at GFDL, looking at our next generation ocean models, a number of different advances that we are actively pursuing in the next couple of years. The crown jewel of this is coupling the interactive Antarctic and Greenland ice sheets. This will be the first model that GFDL, and among the first in the world, to actually couple a dynamic ice sheet melt model to a physical climate model, and we can see how that meltwater will affect the ocean. We plan to move to a non-Boussinesque implementation of the model, improve vertical coordinates, include tides, replace a background diapicnal mixing with mixing associated with internal tide breaking, and just various other improvements to model physics, all with the thread of trying to improve our projections of sea level as a unifying theme for one of the science goals of OM5 and CM5. But we don't have to wait for the interactive ice sheets now to start looking at some of these questions. This is some work by Professor Rebecca Beedling at Temple University, who spent some time at GFDL recently looking at meltwater perturbations in the Southern Ocean. In this high-resolution CM4 model, we see a much better representation of the Antarctic slope current, which acts as a barrier between the ice sheet and warm circumpolar deep water that is brought up onto the shelf. So unclear what this would do in terms of feedbacks for the Antarctic ice sheet, but it's an area of active exploration. And similarly, Jan-Erik Tesdal, a postdoc of mine, looking at the reduction of the Antarctic bottom water formation along the Antarctic shelf. This is, again, another one of those ventilating water masses that is sort of like a cooling factory for the deep ocean. And we see a large sensitivity to how much that gets shut off as a result of warming, and depending on what model resolution we have. So take-home points, it's possible to get the global mean sea level right through compensating biases, but what does that global mean value really tell us? We still have a lot of work to do to understand where that heat and carbon get redistributed throughout the ocean, how the offshore-onshore connections between steric height play out. Still more work to do in that realm. It matters what the local sea level projections are. Our long-term AMOC response matters, particularly for US East Coast sea level. The connections between the broad scale basin circulation are very important for sea level. The steric heat anomalies, changes in heat anomalies and their interplay with mass redistributions can give us some very important information at short time scales, leading to enhanced predictability. And finally, sea level is a unifying goal and science theme that will, among others, that will guide the development of our next generation ocean and climate models at GFDL. So thanks for your time today. If you have more questions, I will be around throughout the day, and I look forward to meeting you.
So thank you very much for that. Both Tony and I forgot to say that we're holding questions until the end. We're gonna pull all of our speakers back up for a 30-minute question and answer session and panel afterwards. So we'll move directly from this on to our next speaker. And I'm gonna ask Rachel Schwam to come up and introduce our next speaker. It's Kevon. Oh, I went ahead. I'm so sorry. It's Kevon Riney, who's a professor in Department of Geography and School of Arts and Sciences. And so, Kevon, I'll let you introduce our next speaker.
Rachel and I planned last night to do a quick switch. Good morning, everyone. So it's a distinct pleasure to introduce the next keynote, being someone that I've known for several years and being a fellow Jamaican working in the field of climate change. So Orville is a coastal ecologist. Dr. Orville Gray is a coastal ecologist by training, and he holds a PhD in environmental biology from the University of the West Indies. He has over 20 plus years experience working at the intersection of climate change, adaptation, and financing. He's currently the head of secretariat for the National Adaptation Plan Global Network, which is hosted by the International Institute for Sustainable Development based in Ottawa. But prior to that, Orville was working as the regional manager for the Caribbean at the Green Climate Fund. So he lived in South Korea for 5 years, and now he's at Ottawa, just got in time for the winter. And so, you know, I think with his experience, one of the unique kind of advantages with Orville talking on this topic around the human dimensions of climate change is that he's worked at the intersection of climate science, policy, and advocacy. And so I think it builds perfectly on the previous talk by John in terms of thinking about some of the kind of human-centric issues linked to things like sea level rise and increased warming. So with no further ado, I welcome Orville to the platform.
Morning, everyone. All protocols observed. Thanks, Kevon. It's definitely my pleasure being here today, and thank you to the Rutgers family for the invitation. I've certainly been enjoying it since getting in last evening, and certainly enjoying thawing out a bit. You know, when I left Ottawa, it was about 2 degrees, and it was warming up, so. No, the last presentation was wonderful. I sat there and I was like, maybe I need to come back and sit in the 101 lecture. Maybe there's something there I can enjoy. So this is where we are. This is where I'll be speaking. And just for everyone, I'll probably take it down a notch, a little bit more of a storytelling, so to speak. I have a slight bias towards a small island developing state perspective, but I'll try to be as cover as much as I possibly can. All right, so I'm going to start here. I was planning to ask, if how many people in the audience do not believe in climate change, but I don't think I need to. But I'm going to start with this slide. Generally, you're going to some presentations and I'm trying to avoid the doom and gloom, of course. There's always this slide that have been used extensively over the years with a polar bear on a sheet of ice. And it drives a lot of different questions in the minds. But this is the one that I use in terms of climate change. And why do I use this one? Most of us, when we hear about an iceberg, what do we see? We tend to see this bit. And that's what we tend to understand by it. But most of us miss this bit. And, when we talk about climate change, that's essentially what has happened in my experience. A lot of us know a little bit about it, but there's so much that we don't know. And this is where that human dynamic aspect comes into play, because when we do talk about climate change, sometimes we have to remember the audiences that we're engaging with and try to expand that viewpoint to the point that they can understand a little bit more. So for instance, when I have the opportunity to speak to local audiences, farmers, fishermen, etc., it's like, no, I can't go there, and unfortunately, John, I can't go and speak like you. They will tell me to go home, So I have to try and remember, okay, what is it that I'm trying to bring home, and how am I going to meet this little target audience? So I have to figure out how to capture that full experience. But here's the science side of it. I can't come to Rutgers and not put the science up. This is a science story. And there's a lot that's happening here. And, don't be scared of the numbers. But unfortunately, the big one that we tend to track is this little bit here. Global temperature, where is it going? From a small island, one of the things I can say to you, I've grown up, and there used to be a song called 96 Degrees in the Shade, right? The last time I went home in summer, it was no longer 96 degrees in the shade. I would have been happy to have 96 degrees in the shade. It was boiling hot. So every time I speak to persons at home, they go, it's hot. And I'm like, but it's always hot. They're like, no, it's hot. So, there's a lot that's happening where climate change is concerned. Unfortunately, we're putting out a lot more of this. It's getting hotter. And, when you speak of people in the global south, they tend to get it. But then when you come to the global north, things are also happening. So the message is now far and wide. No one is escaping it. Everyone is being impacted by it. I'm going to focus a little bit more on the adaptation side. So trying to avoid the doom and gloom of putting out emissions. But speaking to, for instance, the adaptation side, unfortunately, this is where things kind of go a little bit south. When it comes to climate change adaptation, it tends to be seen more in respect of the common good. So just like how we think about air and water, these are things that we think should be always available, not polluted, and free. And when we think about adaptation and where we're doing, the challenge here is understanding this aspect of it. Because in terms of how we look at it from a finance perspective, we group countries based on how their economies are performing. And you have low-income countries, emerging markets, advanced economies. And you've heard the terms first world countries, third world countries, which is kind of weird because that definition actually came about because of a world war. But we've kind of stuck with it, and we've advanced with it. But here's the challenge, is that, adaptation costs will reach approximately 0.25% of the global GDP. But what does that mean for a small island state or for an LDC country? There's a big variation in how this translates. It's very difficult for us to understand what financing is required. When we look at, for instance, what countries have been putting out in their reports, particularly to the United Nations Framework Convention on Climate Change, in terms of the cost on adaptation, we see some numbers and we shake our heads and we go, nobody's going to fund that. We have plans that say, for instance, the cost to build resilience is $26 billion in a country like Nepal. Who's going to provide $26 billion to build resilience in Nepal? You have roughly around 154 developing countries classified under the UN. Looking at all the numbers and averaging it out, the average is $27 billion. That's for 154 countries. Where are we going to provide that? The adaptation gap report that comes out every year, that number has been changing significantly year on year. And it's not going up stepwise. It's almost on an exponential trajectory. So things are getting a lot more difficult. And unfortunately for the global south, the global north is feeling it even more, which means, therefore, they're spending a lot more money at home to solve climate change needs, which means that there's going to be a lot less available for developing countries. Carbon Brief recently published, their report using the UNEP gap report. And this is the trajectory that we're looking at. So climate change adaptation finance provided by developed countries must increase significantly to reach a 2025 goal. In 2021, countries came together and they pledged more. And funding went up by, I think, roughly around 31%. Pandemic hit, things went south, and the numbers went down last year by 15%. So that tells you that, there's always going to be a challenge in trying to build resilience. And it means, therefore, we're trying to think about the man in the street and trying to put resilience in systems, in countries, in communities, that's going to allow them to feel as if they can survive the challenges of climate change. There's a big push towards doubling the financing by 2025. But if we're going down by 15%, we're not going to get anywhere close to that figure. There's this system that has been around, the National Adaptation Planning Process. It's been around since the Cancun Conference of Parties under the UNFCCC, since I think it was 2010. Unlike the NDC's, Nationally Determined Contributions, which has been very sexy and gets a lot of financing, the NAP process has gotten fairly little. But that also shows you the dichotomy between mitigation and adaptation. On the mitigation side, return on investment is very easy. Private sector will jump and provide support there simply because they can go in and they can put in, for instance, renewable energy systems, and they're going to get back an investment on their funds within 3 to 5 years. The pension funds will be happy, and I'm sure many of us in the audience will also be happy because that means you'll have a little bit more money when you get to the point where you say, I'm ready to retire. But those funds tend not to go into the adaptation space. Why? The return on investment on adaptation is more long-term. It's around about 15 25 years on average. So nobody really wants to put that investment in. And the challenge with that investment is it's also not easily seen from a financial perspective. Because it's not like seeing, a renewable energy system where you can easily tabulate the cost for energy and see what you're getting back. It's putting in place, for instance, infrastructure such as seawalls, etc., to protect human investment, homes, infrastructure such as roads, etc. And, so there's a lot that's happening in this space here. There's a lot that's taking place in terms of leadership. In this process, there has to be someone who's going to drive that ambition to build that resilience. There needs to be institutional arrangements, funding going in place to support institutions to ensure that they can put systems in place to adapt to the changing climate. There needs to be engagement. So for instance, the Rutgers family, we're all sitting in here, I think we probably have maybe close to 1,000 years of experience, a lot of PhDs inside the room. But that needs to translate into building resilience in communities at the ground level, building resilience in communities, in infrastructure, in institutions, so that everyone at every level can be more resilient, which means that we're in a better position to adapt as changes go forward. There's a need for data, knowledge, and communications. So I was talking to, I think it was Oliver yesterday, and there was a question about the Global South being data deficient. But this is where we all in this audience can provide a little bit more support by being able to collaborate with communities, countries, entities to drive that data. So some of what John was talking about earlier, I was sitting there going, I wonder how I can get some of this work to be tailored to drive some of the decision-making that's happening in countries in the Global South. Sea level rise is a big thing for island states, for instance. How can we be able to help them to provide the data to make those crucial policy decisions that they want to do and be in a position to be resilient over time? Skills and capacities. In this room, we also need to be able not only to build our own skills and capacities, but be able to take that to the Global South and build their own skills and capacities. In my area of work, for instance, in supporting countries, one of the things that's becoming even more concerning is that every time you reach out to provide support, countries go, I need the support, but I can't take it now. It doesn't make sense. And then you stop and you ask, why not? And they say, there's only one person that's driving this process, and that person is swamped. So as much as they want the support, they can't take it in. So the question is, how can we go into those countries, into those institutions, and maybe work with them, providing support. So some of our grad students, for instance, getting them to go into some of these countries, some of these institutions, and building capacity in their systems so that when they leave, there's a little bit more capacity there to take it forward. Provide support to, for instance, universities, etc., in the Global South to build their capacity to bring students through the processes that they can advance into those institutions and build the necessary support that's required. Because the biggest challenge that they have is brain drain. Unfortunately, Kevin and myself are among those that are not necessarily doing it the right way, so to speak. But I'm reminded that, especially in the position that I'm in, I'm able to support a lot of countries in the Global South from the position that I'm in now, that I probably would not have been able to do had I stayed where I was. But there has to be a recognition of how we're going to be able to go in and provide that support that's required. And of course, the big question again always comes back to financing. So, for instance, last night at dinner, I was listening around, and there's a lot of, the deans are doing a lot of work in raising support to do the work for Rutgers. But how can we get some of that financing, not just to do the work for Rutgers, but to push that data, that's, the science behind it, the capacities behind it, out into the rest of the world, into communities, to build that capacity that's required. So here's where things get very interesting. This process goes to one that says it should not be prescriptive. So it means, therefore, you can't go into countries and say, here's how you are supposed to do it. Why? Chances are you don't have that lived experience. And I can tell you, I've sat in many conversations with donors coming in and literally telling you how to do something. I remember sitting in a meeting, a UNFCCC meeting, and I was sitting around the room just listening. And I had a negotiator from the US said, we were talking about adaptation and ports and development, and the person said, but what you're doing is leading to maladaptation. And I stopped and I said, okay, where should we put the port? We can't put it on the mountain because the ships can't go there. I can't move the people from in the valleys because there's flooding there. I can't put them on the mountain because if I do that, then you have soil erosion, you have excess surface runoff, and that leads to a bigger problem, and then you say that that's maladaptation. So there has to be an understanding of the different challenges and bringing our energy to the table to solve those challenges. So then I said, where's the support that's going to come in to help those people who are living in that flood zone to be able to live in that flood zone by being able, for instance, to raise their housing so that when it floods, they still have housing and they are still able to come and go. Because you can't take them up and put them elsewhere because there's not enough land, especially in small island states. So it's to be able to come to the table together, put our heads together, understand the problems, and help people to build that resilience that's required. So it's being able to go out and understand the country concerns and help them to drive a country-owned and a country-driven process to building the types of resilience that they need. Under the UNFCCC, they've identified that there are roughly 139 countries that have already advanced down this path out of 154. I think this number was maybe in around 2018, so it should have increased by now. In terms of plans that have been submitted to the UNFCCC, there are 47 plans submitted. And this has given the impression that there's not much going on or that countries are not engaged or doing anything. But when we check, we recognize that many countries are actually very advanced in the preparation of these national adaptation plans. While they may not have submitted them, they're already doing the work and doing the implementation. Because that's one of the challenges. They can't sit around and plan and then do implementation. They have to plan and implement at the same time. Survival, right? This is something that you will always see around. And I think to some extent, when you look at John's presentation earlier, it came up to a great extent. The bulk of the emissions and where it's coming from. And then the most vulnerable. It's a very scary picture when you look at it that way. It doesn't mean that there's not vulnerability in the global north. There is. And John mentioned Hurricane Sandy and the impacts on the East Coast. And I was talking to a couple of friends earlier, and I said, I remember speaking to a colleague of mine, and I was saying to him that, it's for the United States, this climate change conversation is going to get even more interesting and important in the years to come. This was before Hurricane Sandy. We got Hurricane Sandy in Jamaica as a Category 1. We did have some impacts. Not long after that, the eastern seaboard felt Sandy. New York was flooded. And the level of flooding that was seen was significant. We're going to see a lot more of that. And I think from John's presentation, with the changes in sea level rise on the East Coast, there's going to be a lot more of that. Some of the beaches that we see here in Jersey may probably not be here in the next 50 years when all that sand disappears. enjoy it now while you can. I'm trying to enjoy my little beach at home at the same time. So,
In
in terms
Tuvalu,
of
we are living
experience.
the realities of climate change, sea level rise, as you stand watching me today at COP26. We cannot wait for speeches when the sea is rising around us all the time. Climate mobility must come to the forefront. We must take bold, alternative action today to secure tomorrow. Faftailasi, Tuvalu Modetua.
Interesting, isn't it? Never seen that done, right? So that's Tuvalu. And that's a minister with
Climate
responsibility
change
for
and sea
climate
level
change.
rise are deadly and existential threats to Tuvalu and low-lying atoll countries. We are sinking, but so is everyone else. And no matter if we feel the impacts today, like in Tuvalu, or in 100 years, we will all still feel the dire effects of this global crisis one day. In Tuvalu, our islands are sacred to us. They contain the mana of our people. They were the home of our ancestors. They are the home of our people today. And we want them to remain the home of our people into the future. This is why this call to you from Tuvalu is not just a political statement. It is a call that reverberates from our 8 islands and our 12,000 people to the international community.
That's Tuvalu. That was his story. And that was significant when he did it. And interestingly, just this week, there's a press release coming out from Australia where they've signed an agreement with Tuvalu to provide support where climate change is concerned. But that support, interestingly, and the agreement is actually signed under a security initiative because of the threat, as they see it, with China. So they're providing visas for 250 Tuvaluans, special visas to be able to live and work in Australia as the years go by. You know, I sit down and I thought about it. There are over 11,000 people living in Tuvalu, islands that are going under. But they are not putting in the resources necessary to build the resilience in Tuvalu. It's more about trying to ensure that China is not coming in and having a bigger footprint in the Pacific Islands. And that's where that support is coming from. How many of you remember this picture? And I can guarantee you it's not from a science fiction movie. This was New York City, Canada wildfires. I can tell you, I didn't see this in Ottawa. No big red sunny days like this. But this is likely what's going to happen more as the years go by, especially if we see the type of warming that's continuing across the globe. This is another human story. Her home was flooded, washed away after a hurricane. How do we provide support for her to be able to live in a home that can withstand the ravages of a hurricane? This is another era, flooded homes. I guarantee you that the residents here cannot afford to live in the sort of homes that we look through the windows and we can see. How are we going to ensure that they can stay there and be resilient over the years with a changing climate? This is the story of the child. This is the heat that they're facing. And we saw a lot of this in the last couple of years, especially in Asia, India in particular. How are we going to ensure that they can survive in a warming climate? This is something that I'm more familiar with. Coral bleaching. As the upper waters warm, as John was mentioning, we're going to see a lot more of this. This doesn't mean that the reefs are dead. It just means that symbiotic relationship that they've expelled all the hosts. It can come back, but not if we're seeing the sort of increases in the upper waters of the ocean that we're seeing now. If that continues, this is going to be the standard and we're going to lose it. And for me, that's a challenge because that's where I get most of the fish that I love to eat, from the coral reef. This is lines for water. How are we going to ensure that these people can survive and have water in a changing climate? How are we going to survive that policy direction that provides the infrastructure that's required to build the capacity for these people to survive? Interestingly, all of us here, many of us order stuff from Amazon daily. How are we going to get those ships with our Christmas presents that we're waiting to give the grandkids on time if they cannot go through, for instance, the Panama Canal? Right now, the water levels are significantly low. This is a Fiji story. Sea level rise. This is what they're worried about. Not having a home because of the warming climate, because of sea level rise, and their contemplation in terms of what their future looks like. How are we going to be able to provide that support that's required for these people to be resilient? And I'll end with this slide.
Time the sea was low. Now we think the high tide can go over the sea. Climate change affects us a little bit. Sometimes it's very hot. Rain never falls. With too much sun, too much hot.
I think it's not fair. They should think of our children in the future.
It's very hard to plant cash crop now. We plant just to eat. The fish got smaller now, and it's harder to find the fish.
The root crops, they're growing up. The wind flowing like this and pull it up.
There's another 10 cyclone incoming. Some young boys, they have to relocate up there. We are old men, we can go up there. This hill just it never affect us, the old men. We have to stay in the flat land.
Yeah, so that's a challenge. And that's a challenge for us here at Rutgers. We're in an academic setting, yes. Do we have unlimited financial resources? No. But there's a lot that Rutgers can do. There's a lot that we can do as academicians. There's a lot that we can do as people in having those conversations, in driving those policies that are required in developing countries to build their capacities in their people, in their institutions, in their governments. We can talk at different levels. There's nothing that stops us in the engagement. So I implore you, have those conversations with your congressmen, your senators, your presidents, about the support that we can provide to people across the world, not just those in our backyards. Let's together build that resilience across the world in the face of a changing climate. Thank you.
Thank you very much, Orville. So we're going to take a break, and please feel free to move to the back and get some more caffeine if that's what you'd like. But we will be back at 10:35. 10:45. We'll be back at 10:45, so thank you. So I want to remind you guys, this afternoon, after lunch, we have a poster session with a lot of our grad students and postdocs who are working on the issues that we talk about today. It's just right upstairs. I'll give you some more information later. Also, we have a raffle at the end, right before lunch. So we'll raffle off. You have a little raffle ticket. Oh, I don't have one, but you should have a little raffle ticket in the back of your name tag. So I'll tell you what it's for a little bit later. It'll make sense. So I would like to invite up Rachel Swam, who's the chair, Department of Human Ecology, and she's going to introduce our next speaker on energy and energy transition.
Thank you, Julie. I'm very happy to be here this morning with you all. And I would, and very excited to introduce Ben Sovacool. He is the professor of Earth and Environment now at Boston University in the US, and where he is the founding director of the Institute for Global Sustainability, as well as professor of energy policy at the Science Policy Research Unit at the University of Sussex Business School in the United Kingdom. And I mean, Ben does research on all kinds of issues related to energy policy, energy justice, security, climate change mitigation, and adaptation. He's so prolific that I have him like on my Google Scholar alert for when he publishes, and it's just going off all the time. And every time I'm like, oh my gosh, she's publishing on this now. This is amazing. And so we're very happy to welcome him to speak to you today.
Thank you very much, Rachel. And I really wish I could be there, and I promise to try to come next time in person. It's really nice to talk as well about a topic dear to my heart, energy transitions. And I'll give you a little bit of a teaser. There's actually some positive good news in the talk, which isn't always the case when you talk about energy and climate policy and transition. So I figure it's always useful to start. So many of you don't realize I actually have a background in communication studies. And there's something famous that Aristotle once said. And Aristotle said thousands of years ago that those who control the definition control the debate. And I think that's very true, and it's important when we start even with defining an energy transition. What is it? And the traditional kind of definition that many of you have probably heard, it's very intuitive, is changes in energy supply. If you want to even sound really cool, SOS, security of supply. Substituting nuclear for fossil fuels, renewables for nuclear, or the classic example of Winston Churchill upgrading naval ships that used to run on steam to run on either nuclear power, Trident submarines, or liquid oil. But I think this definition, while it's probably prevalent in like 80% of the traditional historical discussions of energy transitions, is not the only definition. You also can shift not energy sources, but energy devices, prime movers, or technologies that exploit energy fuels and services like air conditioners or appliances or mobile phones or smart meters or electric vehicles. And as if that wasn't enough, I think there's a third dimension as well, which can be, it's the regulatory systems that govern energy. We could shift electric utility ownership. The United States did this 20 years ago in a whole shift among some states to restructure and liberalize electricity markets, unbundling transmission, distribution, generation, privatizing, focusing on competition. And a great example here is a massive energy transition in Cuba in 1990, 1991 that had nothing to do with changes in fuel, and nothing to do with shifts in technology, but the collapse of the Soviet Union, which was a regulatory shock. And finally, you have a whole other stream of work like Rachel sometimes that kind of looks at the time it takes for diffusion, how long it takes for people to adopt pro-environmental behavior or to change their practices to eat less meat, or maybe change how they heat their home, or change how they view cleanliness, comfort, or convenience. You can already see 4 very different dimensions of what a transition might be, and then you can overly complicate it even more by asking questions at what scale? At the scale of the individual, the household, the community, the university campus, the city, the state, the region, the country, or even transnationally. And we kind of sidestep this a lot of our work and kind of say an energy transition is all of those things. It's the socio-technical system that ties together supply, technology, institutions, behavior at all scales. And there's been some good concepts on energy transitions. I'm a big fan of Arnulf Grubler at the International Institute for Applied Systems Analysis, and Charlie Wilson, who used to be at University of East Anglia, now at Oxford. They have a temporal, spatial, conceptual approach to energy transitions, which is really neat. They argue that they move over time from experimentation and learning to the scaling up of units, to the scaling up of industries, to standards, and then market saturation. So there's the kind of temporal dynamic. And then they also argue that it's a spatial dynamic. Innovations emerge in the core, like Watt's steam engine, and then emerge to the rim. So at that time, it would have been Germany and France and Holland, and then to the periphery. At that time, the rest of Europe. Now we would say perhaps emerging from Europe to the Asia Pacific to sub-Saharan Africa. And you can see on the right, according to Grubler and Wilson, some of the big, grand energy transitions of our time. The phase out of traditional biomass and hydropower to phase in coal, and then the phase in more recently of oil and gas and electricity. And you can see that their framework has pretty good explanatory power, and it's telling us that a lot of these transitions do take a lot of time, which I'll come back to. Another framework, just to give you a taste, is one that I used decades ago in my own PhD, where I used large technical systems. This is a framework from Thomas Hughes, who wrote a great book called Networks of Power. And he kind of uses this term, socio-technical system, which he uses is the seamless web. I love that term. The seamless web, not only of technology, but economic incentives, educational institutions, legal rules, administrative practices that coalesce around the system. And this creates path dependence, or what Hughes called momentum. And he also had a temporal element to his framework, talking about how new technologies like the electricity generator are invented, and then they're transferred, and then they grow, they achieve path dependence, and lastly, they create style. And Thomas Park Hughes ended his theorizing in the 1930s, and we picked it up in this piece with two other scholars to say, well, what happens after style? And we added, well, sometimes these large technical systems can reconfigure themselves. Maybe they can go into crisis, or they can drift without actual true leaders, and they could even stagnate and decline, like electric streetcars in the United States, or shale gas right now in the UK. And large technical systems are good as a framework or heuristic because they explain not only electricity and energy, but look at all these other cases we picked up in our review of the applications of the framework: railways, telecommunications, gas pipelines, marine transport, sewage systems, shale gas, flood control, even coal as its own distinct supply chain: coal mining, coal extraction, processing, and transportation. And just to end the theoretical discussion, very provocatively, we did a study a few years ago, myself and David Hess, who's a sociologist, where we interviewed the theorists. And Rachel knows some good colleagues, Tom Dietz and Paul C. Stern, who are excellent theoreticians in our field. We interviewed them, as well as a whole bunch of other scholars who were highly cited in the field looking at concepts. And the term that we used is socio-technical change, but that's just a fancy term for energy transitions, changes in technology or behavior. And I'm amazed that those 35 theorists gave us, when we asked the question, what's the best theory to explain transitions? 96 theories. And in the article itself, we have an appendix, which is almost as long as the article that talks about all of them in order of discipline. This shows you the first four, including Paul's. Their discipline, the authors, and their kind of key constituent components. 96 of them were mentioned at least once. Then we did a kind of content analysis. There were 14 of them mentioned at least 10% of the time. So it gives you a sense for how commonly they're used. So it gives you kind of a hot list. And even these theories: multi-level perspective, social practice theory, domestication theory, LTS, actor network, value belief norms, lifestyles, UTAUT, does give you a very different view of transitions as a concept. This is, opens up, I guess, what a transition is, and it shows you we have no shortage of conceptual thinking across multiple disciplines. Moving away from that, because I know many of you probably don't care as much about theory as I do. What about some of the more empirical evidence? What about case studies and recent trends and kind of market assessments? On the one hand, you have what I already showed you, coming from Gruber and Wilson, that show you these kind of historical transitions in Europe, and you can see now on the right just how long they took, right? The fastest transition was almost 50 years, older than me, and the slowest one took 160 years, which I don't think I'm going to live to be that long. So these are intergenerational decades to centuries long transitions. And there's a famous geographer of ours, Václav Smil, who I enjoy reading. He's very pessimistic, who then looks at this data and concludes, well, based on this data, energy transitions have been and will be prolonged affairs that are impossible to accelerate, even if we resort to highly effective interventions like command and control, regulation, or carbon taxes, or even things like rationing. And Smil, in his own work, presents this data, which has plotted the same data two ways, which shows you the big four global energy transitions of our time: coal, oil, gas, and nuclear. The top graph shows you just, temporally how long they took. It's hard to see the numbers that way, so the bottom graph just adds up the numbers. And so the big transition to coal, even though it had so many productive attributes over what it was replacing, it was superpower, it had steam engines, and a whole variety of other benefits for industry, still took 120 years to diffuse. Oil, 80 years, gas, 85 years. Nuclear hasn't even come close to the 25% mark for energy. It's come close in terms of global electricity, and same with wind and solar. Switching from supply to devices, we also see Arnoff and Charlie and Greg Nemeth, who's a historian of innovation, giving us similarly bleak perspectives, where they've looked at how long it takes to innovate. So that's the left chart, like the formative phase. How long does it take to perfect a steam engine or a bicycle or a compact fluorescent light bulb? And then, once you've got the technology innovated, how long does it take to diffuse through their framework from the core to the rim to the periphery? So the true transition speed is both of them combined. Look at steamships and steam engines, right? Hundreds of years to develop them, and then dozens to decades of years to further diffuse them, right? So absent a few really quick transitions like fluid catalytic cracking or e-bikes or wind power, most of the technologies that we know of take a long time to diffuse. Moreover, this is just individual technologies, or if you want the fancy term in science and technology studies, artifacts, technological artifacts. When you talk about systems and systems of systems, like an electric utility grid, its magnitudes of order even more difficult, right? Because you're having to transition not just fuel, but the entire horizontal and vertical supply chain. And if you also look at the opposite way, how long does it take not to phase in, but to phase out? Bruno Turnheim and Frank Heels have a great study looking at the coal phase out in the UK. And according to them, this is the flip side of transitions. How long does it take to destabilize a fossil fuel that you want to get rid of? And again, you can see the punctuated equilibria that occur in fits and starts. Imagine how difficult it is to predict these dramatic changes in 1920, 1930, 1952, even 1980 and 1985, where very hard, lots of uncertainties, lots of multiple phases of destabilization. And overall, even though they realized in 1953, after the famous London smog, which killed a bunch of people, it still took 50 years to successfully demand-side manage coal to be phased out. And even now, 2020, there's discussions about reopening new coal mines on grounds of energy security. Now, this pessimistic view, well supported by the data, does have some oddities, one of which is at what percent can we say a transition exists? Pretty random, clean numbers here, 5%, 10%, 25% was Smil, 50% was Gruber and Wilson. These also seem like very manufactured numbers. Why isn't it 5.6152%? Why are they always round numbers, kind of arbitrary? A lot of people focus on an isolated technology, but not the seamless web. And we can see different technologies that mimic each other, good examples, or become coupled to each other. A really good example here is railways and telegraphs become coupled, because as you were laying rail, you were also laying telegraph lines, and you had the same labor and some of the same materials like wooden poles, wires, and cables. Similarly with roads and oil refining. The more that you refine cheap, abundant oil, the more that people need roads. The more there's roads, the more that you increase demand for oil products. And similarly, what is the unit of analysis? Is it a steam engine, an internal combustion engine, an oil lamp, a boiler, a furnace? Is it rapid changes in all of these devices, or is it together the entire oil-based socio-technical system? And I'm happy to say that if you flip the unit of analysis a little bit, say you want to look at 5 national energy transitions rather than global transitions, which is what SMIL looks at, and 5 prime mover transitions, you do have evidence here of some fairly rapid transitions that have occurred all in our generation. So these are all post the 1970s, 60s. They all happened really, really fast. Look at some of these transitions, like flex fuel vehicles in Brazil took 1 year to jump to a 25% market share, or combined heat and power 3 years in Denmark after the oil crisis. And then if you look on the right, and you've got really good eyes, you can see the actual number of people affected by these transitions. And the numbers add up to more than 930 million people. So almost 1 billion people on the planet have been impacted in our lifetimes by some sort of rapid energy transition. And we've done a second study more recently looking at heat transitions that were both deep, so they had to affect lots of people, and rapid, they had to occur really quickly. And we've got other evidence as well for transitions that affect another 60, 70 million people, whether it's solar hot water in China, or heat pumps in Finland, or gas central heating, the replacement of town gas with natural gas in the UK. All of these are massive transitions. Look at the UK one, 40 million appliances, 14 million homes, almost half of all homes were retrofitted with gas appliances in a 10-year period. And this leads my colleagues Florian and Carolyn to kind of say it could be that we're now moving into a new era of transitions that have fundamentally different attributes than previous historical ones. First of all, historic transitions tend to be by accident, by war, or by resource discovery, whereas maybe future ones are actually actively governed. We plan together to create a rapid energy transition. Proactive rather than reactive. They had a lot of discussion about new innovation dynamics and innovation spillovers. The example they give is what happened when the German feed-in tariff for solar energy accidentally stimulated Chinese manufacturing. Even to the detriment of German industrial strategy, it sped up innovation dynamics that almost no one saw. So that solar photovoltaics now are so cheap, $2 per watt or less, that they're even predicting they could surpass 40% of electricity supply globally by 2040. And finally, Florian and Carolyn had a lot of faith in the Paris Agreement and the nationally determined contributions, and the fact that only a small handful of states, Syria, Iran, Saudi Arabia, the US, have withdrawn. Even Russia and China are currently abiding by their Paris commitments, despite having wars and conflicts over Taiwan and Ukraine. Moreover, Florian and Carolyn have talked about new policy tools that stimulate phase out. You don't have to incentivize, you can disincentivize. And you can do so by banning light bulbs, incandescent light bulbs, banning cars, banning boilers, as well as changing market rules with carbon tariff border adjustments, right, or differentiated strike prices for carbon, or even doing policies that ensure a balanced debate over things like net zero. I was quite inspired by this article by Patrick that just shows you the actual number of cities and countries around the world that have started to ban cars. And it's a huge list. It isn't just Paris and London. You have Israel, Ireland, India, Sweden, Sri Lanka, France, Taiwan, as well as lots of cities like Madrid, Rome, Athens, Auckland, Brussels, Beijing, and parts of Oslo that also have actual restrictions that are banning conventional cars after a particular date. Which has led some like Citibank to even say that maybe future transitions aren't about supply, they're about demand. And they did this report, a bit provocative, right? Global oil demand growth, the end is nigh, maybe not so true, but they were really talking about the shale gas boom in the United States and how the substitution of gas for oil, for shipping, trucks, power, vehicles, and petrochemicals meant that oil demand for the first time in decades was flat. That's the bottom graph on the left. After gas substitution, oil is about 90 million barrels per day. And I believe now it's closer to like 85 or 86. So it's continued to actually drop above these historic highs from a decade ago. And finally, just to give you a different perspective that's not my own, I happened to have the pleasure of attending this forum a few years ago. They need to rename it. It's called JUNC, the Global Intelligent Utility Network Coalition. It's led by IBM. But for those of you that study energy trends, you'll recognize a lot of big names here. Centerpoint, SDGE, E.ON, TEPCO, Dong, which is now called Ørsted, EDRF, and so forth, Duke Energy, major utilities. And I was at this event that was kind of like, what does the transition mean for them? And to them, it's not academic. It's not about concepts. It's happening now. They are being disrupted. In their view, this is one of their slides. That's why you can see how they call energy storage and solar PV grid defection. That's their perspective. They're defecting from the grid rather than just energy democracy or community energy. But you can see it's like, to them, solar PV, batteries, EVs, distributed generation, net metering, smart meters are already threatening their business models, and they don't know what to do. And you even have some utilities presenting slides like this that are so desperate for business models in 2030 and 2040, they're talking about selling sensors. They're talking about selling insurance. They're even talking about selling bonds and financing. So your energy utility is a bank, and you go to them for loans. That is how disrupted these companies think they'll be in a world that has flat demand for energy services, and they're not making money anymore selling kilowatt hours or cubic meters of gas. And this is the last slide from GEUNC. They also showed for Houston, Texas, a bit far from here, but not so far, in 2015, so 7 or 8 years ago, these were the 67 startups that were changing demand in the home. Smart homes, smart meters, home energy management systems, et cetera. And we were so inspired by this graph that we were like, man, 67 startups. I wonder if we did the study in 2020, how many would we find? And we did. We replicated the study, and we did 31 expert interviews, and we did 37 site visits all around the UK, which has good markets for smart home technology in Europe. And the number is now 267. We identified 267 smart devices in the home that can change lighting or appliances or entertainment or do integrated solutions like Hive and Nest, or silly stuff like robotic vacuum cleaners and lawnmowers. But I like this slide because keep in mind that in 1995, when the internet was just Netscape and the World Wide Web was just coming into invention, very few people would have thought or envisioned 20 years later, we have these smartphones that can do things like visualize energy and do a whole variety of other apps. I don't think many people would have predicted that. So there's a good example of just 2 decades ago, how off we might have been at predicting the rise of a whole host of innovations being backed by 300 of the Fortune 500 companies. So to conclude, because I certainly want to open it up for questions, let's not forget the first bit about Aristotle. Definitions of an energy transition abound. So whenever you see studies, reports, assessments, it's always, think about how they define a transition. Is it electricity supply or energy supply, energy demand or energy consumption or use or distribution? Always check sources, data, assumptions, thresholds, what the unit of analysis is, because there are lots of competing and unclear definitions of what a transition can be. Keep in mind those early slides about conceptual tools, 96. We've got 96 different concepts that we can use as researchers, and probably more because our sample of experts was a convenience sample. Is this a problem with academia? Because if you need 96 theories to explain a single phenomenon, does that mean none of them have explanatory power, none of them resonate well? Or is this a celebration of diversity? If there are 100 ways to interpret a play or a film or a piece of art or a song, doesn't it make sense there are 100 different ways to interpret something as big as an energy transition? My own take is that I think all of them are useful. They all have strong fits, but they all have also misfits. And so they're all partially wrong. There's no unified notion of an energy transition. There's no unified theory like Darwin and evolution. So I think it all depends on your research questions and your scale of analysis. So they're all useful, but none of them gives you a complete picture. And finally, for those of you that are researchers, the 2 hottest topics or the multi-level perspective and social practice theory. Those were mentioned in almost half of the interviews. That may mean that you want to use them because everyone knows what they are, they're very current, or it may mean you're like, no, I don't want to use them because I don't want to do what everyone else is doing, and I want to use something new and novel, so I will intentionally not use those two overused theories. Going back to the 10 transitions on national supply and energy demand, the causes are very complex. Some of them were caused by world wars, like the French nuclear rollout, or the end of World War II opened up Kuwait so that we could extract oil safely there without being shot at. There was a famine behind the Chinese cook stoves. The oil crises were really behind the Danish combined heat and power program and the Brazil pro-alcohol program for ethanol, which was a precursor to their flex fuel program. Only one of the 10 transitions was demand-driven, air conditioning, and that's arguably not even in the right direction because that's probably towards unsustainable heating, ventilation, and air conditioning practices. Future transitions, though, don't have to follow this logic, right? They could be driven not by scarcity or not by kind of chance, but active governance. Maybe they're based on scarcity rather than abundance, and maybe they're based on changes in demand rather than changes in supply. And I think there, as much as Grubler and Wilson and Smill and others are telling us, while history can be instructive, I don't necessarily think it is predictive. And I do think that we're discovering ways to accelerate future transitions in ways almost unimaginable, even just a few decades ago. And with that, thank you for your time.
Thank you, Ben. We're going to ask you to hang on online, and we're going to have one final talk. And then after that, we're going to all come back together. So we'll pull you back up on the big screen and we'll have a discussion. So for our last and final presenters, I'm going to ask Jorge to come up and give us the introduction.
Thank you, Julie, and to the organizers for the opportunity to contribute to the launching of the Rutgers Climate and Energy Institute today, even by this small token. Today, our guests, Kristen Thielking and Elizabeth Robinson, will illustrate for us, through their remarkable work, the role of the arts, the humanities, and larger communities for creating and advancing the solutions we are looking for. Their work epitomizes what collaboration and synergy is among different media and various forms of knowledge. Elizabeth and Kristen are artists, educators, collaborators, located in Eastern North Carolina and Central Wisconsin, respectively. They are multidisciplinary artists who create large and small works addressing ocean health and the climate emergency by combining glass, paper, poetry, scientific data, imagery, words, sound, and light. The two are the visual artists, members of Catching a Wave International, an interdisciplinary collaborative that brings scientists, artists, and geographers together to create public awareness about current research pertaining to ocean health and sea level rising. You can find more about Kristen's and Elizabeth's work on the conference website. And for more conversation with them after this event, you are all invited to the launching of the new minor in creative expression and the environment, a minor that is a joint collaboration itself between the School of Environmental and Biological Sciences, the Mason Gross School of the Arts, and the School of Arts and Sciences. It's open, the minor is open to all New Brunswick students, and we'll meet today at 5:30 at the Civic Square Building, room 110. But before we get to there, please join me in welcoming Kristen and Elizabeth with a round of applause.
All right, we're gonna figure out this mic thing. Okay, hold on, so wear it. I've never been mic'd before.
We'll be dancing around the stage like ants. We do that.
How does that sound? Pretty good. Normally, we just shout at our students, but I apologize for my voice, so this is good. All right.
We're gold.
Let's do it. All right.
It's not your scientific presentation.
I know, we have a different style.
But thank you so much for having us. It means the world to us to be here and to be participating. And also, we're hoping for a nice big exchange of ideas, possibly future collaborations. We'll play that further on. But
yeah, we have a nice group of healthy brains out here that we're going to be tapping into later. So be prepared.
I got the controls.
All right. You're good. Okay, so I'll start off with this one. So it's always fun for us to present with scientists because we definitely have very different images to show you guys. And I just want to explain a little bit why we feel like it's such an honor and also such a pleasure to be presenting our work and maybe what you might think is an out of context scenario. And we'd like to start by talking about what art can do to a mind frame, to an experience, and how that can be connected to the message that you all want to get out there, which we believe is such an important part of the solution. So art, and I'm sure a lot of you guys are in a really great place for art. You have an excellent art school here, very good reputation, close to a lot of museums. But one of the things that we love about creating installations, which is basically art that activates a space instead of just being on a pedestal, is that it allows the viewer to immerse themselves in the piece. So, and there's multi-sensory activation that happens when you help your viewer and invite your viewer into an artwork. So you can see here are some of the pieces that Lisa, Beth, and I have done. There's a levitating glass piece. This is up right now, actually, the one in the middle. Lisa Beth's cast paper boats. They're actually cast from an actual canoe. The one on the left, I created with my husband, Kevin Burnett. It's a public art piece that has quotes about the environment that are illuminated in the glass pieces down below. And it's celebrating an important historical river in part of Wisconsin. It's a moving piece. And then the piece up here is a piece that celebrates the Dictionary of American Regional English and how cultures combine. You walk through, you touch the pieces, they knock against each other. There's a sound, there's a reading component. So we're interested in art that creates a dramatic, visual and visceral experience for the viewer, and then we draw them in and they have a more intimate personal experience. And then ideally, after those experiences, they emerge from the piece and interact with the other people who have been through it. So you can imagine how this framework for illustrating an idea, let's say Ben's wonderful information that was pretty exciting to see, how can we translate his information in an experience so that people who are walking through a park have Ben's lecture and absorb it?
One of the things you can think about when you think about installation is that the two key components is that it's based on transformation. It's transforming a space. So by going through that space, you have a different experience. And it's, I'm having a blink. It's about transformation. It's also site specific. So when you build an installation, you're building it to that area. All of these will change based on where they're placed. Like the ones that Kristen's got on the bottom left, that's a permanent installation, but the rest of these are transitory. So they'll change based on data, based on space, based on location. what's nice about that is you can keep up with current issues, current questions, current environments, current data. Like, I'm really excited about your pictures. I want to use those pictures, John. Those are really good. And the boat pieces are they're talking about the human aspect of climate migration. In fact, the one in the middle is the title of the exhibition is Mitigation. So what we do is we bring the science to the average viewer as well. So something that might look really less than glamorous in a white paper can be translated in a way that you can experience and it reaches people. So art's more than outreach. We'll talk about that in a minute, but I think it's really important to note that it's a great marriage, science and art. We're cousins, we're siblings.
And I would say too, because we're trained, we sort of, in visual literacy, we sort of forget that not everybody has that opportunity to have that training. But our whole goal is to capture the audience and hold their attention and sort of create a mindset where they're receptive for information. I mean, this is what we teach our art students. So you can see how it might be a great vehicle we want to capture the public with this climate change information and permeate it and make it more memorable than maybe other modes of communication that we've used in the past.
So this is our key collaborator right now, John McCord, who's the Director of Engagement and Outreach at the Coastal Studies Institute in North Carolina. It's on Roanoke Island. Some of you probably watch that program, Outer Banks. It's out there. Yeah.
And we got to go.
I know, it's great. I love going to the beach. But what happens is John's a tech head, which is great because for us, we're technical about our work, but we need somebody who's also willing to play with us. So one of the processes that we've used a lot, are the waves making their way around? We've got things to pass around for everybody to
where's the wave right now?
The big waves.
All right, okay, it's a little heavy, so I
Yeah.
forgive you. But one of the reasons why we want you to feel it is we want you to feel the weight and look inside of it and think about it and feel the surface. Because the surface is an actual wave that we captured. It is a moment in time. And you can see, I think Tony said last night, was it Tony who said the capillary waves?
Yep.
So you can see all those intricacies. They're actual size, actual capture.
And what's great is the physicality of it becomes metaphor because waves never act alone. Everybody likes to draw that C curve. There are waves like that, but really waves are communities, right? No wave is a single component. And so we can take the metaphors and make them visual. And that way we can communicate these ideas and it becomes fun and interesting.
John is also super cool because he photographs underwater, like he's always diving. And we thought, okay, we definitely want to work with him.
So the photogrammetric process, just in case you're not familiar, is a way of capturing 3D underwater. It's used to chart coastlines. It's used for a lot of things now. In the CSI case, they use it to capture the graveyard of the Atlantic. They do a lot of research on shipwrecks out there. And so a friend of mine was a video guy and he introduced us to John because Kristen was like, hey, I want to capture a wave. I want to get that moment. And so it took 2 years for us to just iron out the details and get the grant funding. But when we finally came together, it really started to go.
So you can see John on the left with an image of the two-dimensional capture. The rig down here was designed and fabricated by my husband, Kevin Burnett. It's loaded with cameras.
Really great over water.
Yeah, and we got a really wonderful research grant from the University of Wisconsin-Stevens Point, but we also got a grant from ECU. And we also had lots of time and expertise donations from Coastal Studies Institute. So this is another model that we would like to explore with you guys about how you can increase your fundraising, increase your donor pool by combining expertises and sort of having donors maybe donate outside of their field of interest because they want to get involved. So this was, and then that's the wave tank up above, where we captured the wave. So all of these cameras fire simultaneously. Some of you guys may be familiar with photogrammetry. They fire simultaneously so that you can, have all those data points that you then mesh together, upper right, and that was John's hard job. We felt so bad. But he figured it out. It took all week. And then he was able to print it out in a 3-dimensional model, which we'll show next.
So one of the things you can think about is instead of saying a technology can't do something, say, why not? Sure, let's try it. All of our innovation comes out of those questions. And so these are the models. We've got one from in the wave tank, and we've got one from out on the Albemarle Sound. So we took the whole rig outside because the water wasn't big enough. And photogrammetry doesn't like anything moving, and it doesn't like anything shiny. So a big part of what took us, we actually only did it in 4 days. John wound up having meetings on Monday for the week we were scheduled out there.
But we did have the solution over lunch on a paper napkin.
Yes.
It really does happen.
It does. And I kept the drawing. I have it like glued in my journal. But to capture the surface was a whole nother thing. And we're dealing with things like just communication going over wires on the right time, all at the same time. And we're talking about thousands of seconds. So it got really technical and really frustrating for John. And we just had to be there to make the waves. Yeah.
How can we help?
Yeah. So the model on the bottom left is the 3D printout. We went through 3 printer heads. One of them took over 50 hours to print. We've got a second one that took over 70 hours to print. So something to keep in mind is that art takes time. It takes time. You guys know this from research. It takes time to do the research. It takes time to produce the objects. And then finally, we got to the items that are being passed around, the pieces. Right now, we're still fine-tuning this work. We'll talk about that in a little bit.
Yeah, so you can see there, we're very interested in how technology makes it possible for artists and scientists to communicate in those memorable impact and visceral ways, engaging the senses. Because we believe, and there's research out there that you guys are probably more familiar with than we are, but that how those core sort of visceral memories of childhood in nature are proven to inspire more pro-environmental behaviors. There's been papers and research written about that, and we find that really intriguing. Can we create a core memory through a piece of art that sort of taps into that sort of memory of the ocean, playing, all those sort of positive psychological experiences of being near water? We know that humans benefit from that.
And also to inspire curiosity. When you see something like this on the table, you don't expect to see a wave out of the ocean. It's an anomaly. It's exciting. It's strange. It's what is that thing? And then when you pick it up, the weight of it is also, there's so many novels about the weight of water and what water does and how we live with water. And this is a way we can communicate these ideas, but also as scientists, something you should think about is those new technologies. Like we just heard about a camera today.
Yes, David. Yeah.
Thanks.
He's our new best friend.
We're going to be talking to John about this when we go home. But just the things that this camera can do, we're going to think about it in completely different ways than, you have a goal. You're taking slices. They're like core samples. We're going to be like, what's happening in that space? How do we talk about what's happening in that space? How is what's happening in that space relevant to how people are living at the coast, how they're choosing their technologies? So it becomes a dialogue. So when you bring artists in at the beginning, it's a different dialogue. I'm not saying we function beautifully as service providers. We can make anything you have look great. But if we can co-design, we're going to ask you crazy questions and you're going to like it.
I will point out, and as you guys are passing the wave around, look inside of it. There's words, there's images, there's some topographical maps on the top of that are from off of Roanoke Island. So we have this object that is sort of on the surface literally, interesting, maybe spark some ideas. But then again, that idea of like an initial, we want to spark initial, like an aesthetic experience, but then you make a discovery. There's something in there. I want to figure that out. And that idea of sort of creating a moment of curiosity is that brain switch that we want. So each one of these waves can have different imagery in them that relate to a specific moment of research that we want to celebrate. So the next series will be celebrating diatoms and copepods, and we're going to be including information about how oxygen is produced by some of these microorganisms, because most people don't know about that. And maybe they don't really know that it's even interesting. But if we can embed it and then trick them, not trick, but like seduce, right? And be like, what is that? What is that crazy creature? And then realize like, whoa, they produce more oxygen than the trees.
Millions of them all around us. It's crazy. Yeah. It's exciting. So you could be part of our project.
We're fun. Do you want to start with this one? Okay. So over the pandemic, because we believe that part of the solution is connection, just like this amazing institute that you guys have brought together. I mean, we think it is probably the most important solution, that you're bringing great minds and people who care together.
Jealous.
And we were so separate during the pandemic, and thinking about that with our group. And we'll introduce our group in a minute. We were thinking, how can, art, it requires people to come together, and this is so anti-pandemic behavior. And so we started cutting the two, we have two actual waves we captured, and we started cutting them like brownies. And we started sending them to people that we know care about the ocean, and scientists, policymakers, friends, kids, classes in Ireland who recorded their thoughts about the ocean. Yeah, here we go.
Been to, where are they, the Maldives? That's exciting.
Yeah. They went underwater. Some of the divers who were working on some coral destruction analysis videotaped themselves with the waves under the water. But
even GirlCon. So we're reaching out to high school students and younger folks as well, just to be part of their conversation. They keep bringing us back for art and tech.
So the idea, and Shona keeps reminding us, Shona Patterson, like there's one ocean. Right? I mean, you guys maybe are all familiar with that idea. We're like, no, there's not. There's Atlantic Ocean, Pacific Ocean. And they're like, no, it's one ocean and it connects us all. And we thought, wow, if we could send these out, these are all part of that same wave. And it's sort of this idea that, maybe you'll feel a connection with each other when you receive this, a connection to the project. And there's a traditional pocket labyrinth that people carry around. My friend was studying them in Ireland and Scotland, where you feel it. Like, so if you can't walk a labyrinth, for meditation purposes, you can have it in your pocket, almost like a rosary, and you feel it and you're sort of meditating. We thought, wouldn't that be cool if you could have a pocket wave and you're always feeling it and thinking about, the ocean, having it on your mind. And so that we made them smaller and then are disseminating them. And eventually we'll show all the photographs in a gallery space with everyone's picture, whoever wants to include themselves. It's optional, obviously, with a map of where everybody is. So another visual that describes our connection.
So one of the things we want to present to you today is a successful collaboration model, talking about transdisciplinary communication, how you reveal narratives. We've actually devised a little checklist to go through, about 11 easy points, including funding models, and how you get everybody together at the table and make space for ideas. So these are like friends, family, everybody. We've got more folks. We've got movies of people.
And we're happy to include all of you. Anyone who wants to be a part of this project.
I'll take your names.
Yep.
I've got a book. So this is part of what we started doing. We started thinking about what happens when you do bring that anomaly to places that you don't expect. How do we kind of push people into thinking about the ocean in a way that they don't overall are going to the beach?
And that moment of surprise is also really important in when you're creating a piece of art. You want to sort of grab your viewer out of their just assumptions or expectations. Even walking down the beach for the first time, your brain is going to be activating and firing different parts in a different way than if you've walked that path 10 times, right? So this is a prototype. We're still like expanding on it and perfecting it, but there's a motion sensor in it. So when you walk up to it, it lights. And then the sound that you can also access from the QR code will be either like, it could be, I keep thinking of Ben's voice.
Yeah.
It could be Ben talking about those quick transitions that are happening.
We've got school children, we've got recordings of oysters. People don't realize how
bottom of the
noisy the
ocean.
ocean is. It's like New York City down there.
Or
There's a lot
cats
going
loud.
on.
Or wave sounds.
Popping, cracking, whooshing. It's not just whale sounds. I think that's what everybody imagines. And something to think about when you think about contemporary environmental art. So we're really focused on environmental art here. But when you think about contemporary environmental art, I think about this we think about this combining with the new climate, and that it's not a commodity. People think of art as a product. And art is an experience. So if we change, and I know right now interactive art's really popular, and hopefully that'll continue. But when you start engaging and when you start having this dialogue, one of the things you want to think about is, how do you want people to experience the science that you're presenting? How do you want them to perceive it, absorb it, carry it with them? So we've got waves on ice.
So if you're wondering, an iPad and cameras do not work very well in 15 below. So this was just a lake near my house that my poor family members had to set up because we wanted it on the ice, just as another example of how we could display these. And, moving through this piece obviously was very different than when it was set up in a museum or a gallery or a park, in the summer. But you can see how it's large. It's sort of this grand landscape. What is that crazy thing? I mean, all the ice fishing people, Orville, you probably know them in Ottawa. They're tough beyond belief, but they're like, what are you doing? And then, of course, they wanted to come and learn and see what it was. It was already working by accident. And then when they're lit, you can see what's embedded in the glass a little bit easier, too.
And in case this is feeling too feely, something to think about that a lot of people don't know is that art has really set formal guidelines. We have elements, we have principles. We structure every composition this way, whether it's 2D or 3D, now 4D with time and motion. There are a set, so we also have some rigid standards that we comply to. And then when we collaborate with scientists, we have the pleasure of bending those or saying, well, what if we didn't use it this way? When does a line become a texture, right? When does a line become a shape? When does texture become a shape? Cookie Monster, right? Giant texture, big shape. But you think of him as an auger. I don't know, whatever, Cookie. You think of Cookie as I was like, whoa, gender panic. But you think of Cookie Monster as an entity, but if you take him on formal principles, it's really a very laid out, rigid kind of evaluation. And so we're familiar with that kind of structural basis, and we can relax into it together. So when you're beginning at the ground level, one of the first things you kind of agree to is, okay, we're going to relax. We're going to come in. It's going to be hard, but we're going to be flexible.
Well, and we can translate those design principles and elements for whoever we're working with to sort of manipulate the information and deliver it in the way that we want the viewer to experience it. So it really is effective.
Yeah. And eventually I will take no for an answer, but it's going to take me a while to take no.
So this is our lovely group.
Yes.
So Mariel is up there. Right,
she's the human geographer.
She's our human geographer, Rachel, wherever you are. And there's let's see, who here you introduce.
Okay, so Dr. Shona Patterson is a coastal scientist. She's based out of the UK.
She's on the right.
Right now, she's at Brunel University. Mariel is a human geographer, loosely connected with University of Wisconsin-Madison. Martin
Letitia.
Thank you. And Hester White have started their own coastal program. So they do all kinds of things from evaluations of wrecks. Martin does the kind of thing where you go out and speak in a court on behalf of Rex, and he's the scientific expert. And then Aoife is, she's kind of backed away a little bit, but she's our communication person. So now Hester's taken over the communicating. So everything on the website, we say, thanks, Hester.
And Hester basically organizes. She's the brains of the operation, truly.
She's our Julie. So we see ourselves as co-designers. And I think that's a big change in how you perceive yourselves. You've got to change, not change, but add to how you see yourself, not just as a, finder and researcher and categorizer of information. I know you guys have like a really big time delay in getting published, which is frustrating, but it kind of matches up with the art delay in creating, so it works out. So when you think about what makes a successful collaboration, you want to think about developing transdisciplinary collaboration skills. You have to learn the other one's language. You don't have to understand it deeply and profoundly, but you need to know what people are talking about. So like for me, because I'm a super nerd, I'll go and read abstracts so I can learn the terms, or I'll look at graphs and go look everything up. You have to do your research. It's a little easier with art. Oh, you have to go to a museum, alas. But familiarize yourself. So if I talk to you about color and texture, you know what I'm talking about. And think about micro and macro. What do I need to know right now for this conversation?
And we get to talk about this work in Frontiers magazine, which certainly wouldn't have happened if it wasn't for Shona and these guys and Marilla and Martin. And having a transdisciplinary group means we have access to all these different again, funding, grants, audiences, social geography. We went to a really wonderful conference that Merle Ukele's was the speaker. It was
when you throw things out.
I know.
Discard studies. Yeah, in New York.
I mean, what artist ever gets to go to a conference like that?
It was really different for us, but really exciting. So this is our website. Catchingwave.org. If you goof it up, you're going to get a lot of surfing.
Yeah, you'll get a lot of surfing. Make sure you put catchingawave.org.
But the sections across the bottom kind of sum us up. What are we doing? Who's doing it? When do we do it? What do you want to look at? What have we done so far?
And there's a video in the middle that we'll share with you guys at the poster session of how we make them.
Here's our most boring slide.
Don't say that. Don't say it.
But this is the one we're going to start the checklist here. So if you're really interested in this, you've got a copy of everything. We'll share anything we've got. But so you start out, the first thing you want to do is the group, as a group, not individually, as a group. Just organize it how you like, but identify the content. What do we want to address? And most importantly, who's the audience? Like, you guys are easy. You're already in it to win it, right? But if you're speaking to people who might be funding you, who don't know anything about any of it, you're gonna organize the conversation differently. Then you're gonna invite people to the table to have a discussion. So there's a lot of conversation going on here, as it should be, right?
And you guys are doing it. You're doing it with the Institute. It's fantastic.
It's really.
And you've included the humanities and the arts, which I think is
key.
Really,
well, that's very progressive. We're saving for one of the questions. But you want to identify the key points you want to communicate. And it's okay to just have one or two. Everything doesn't have to be the juggernaut. Okay. What are the most salient takeaways you want your audience to have? So when they walk out of here, what do you want them to remember? And the last one is, what's the goal of the collaboration? This is our sexy slide. What is the goal of the collaboration? What are the ideal outcomes?
1 minute.
Oh,
so we're just going to move a little faster.
Okay. What's the timeline for the project? Do some research, come back to the table. What'd you learn? What are you thinking about making, presenting, communicating? Create proposals. This is the most exciting.
So we mentioned that the waves that we're passing around are prototypes. Our goal is to go bigger and to create a more immersive and more flexible installation that can be mobile, can be a public art piece, can travel to a museum.
We want people to walk through and feel what it's like to be sublimated by the water.
So these lines are a map of research that the Coastal Studies Institute has been doing.
Shifts in coastline over time, sea level rise.
And so we're using John's data. and then creating, walking through that. So feeling it, hearing it, it would be great to smell it. We haven't figured that out yet.
That's smell-o-vision. There are images and text imbued in the glass because we want to have the light projected down. So this would ideally be in a dimly lit space. So as you go through, then that more of that information becomes light.
And then the shadows of the images as you go under the waves will be projected onto you.
You will be the water.
The idea is to connect the human, the viewer, with what's happening, because our point is always that we're not separate from the environment. We're not above it. It's not a hegemony or hierarchy. We are part of it. So if we can, illustrate that through the piece, it's one of our goals.
We're trying to get away from the anthropocentric model and into the full kinship model. And that will motivate everyone to be a better human and to take better care of the planet.
Yeah,
So
we did
thank
it. Did we
you.
do it in a minute? Yeah.
How did you know?
She told me.
Oh, okay. Well, thank you so much.
Yeah, thanks, guys.
Appreciate it. Okay.
Oh, stay up. Oh, stay up. We were not
Nice.
released.
So I would like to invite Orville up, and John, I think, just ran off. Of course, good timing. Okay, and then if we can bring Ben back up on the big screen. It's okay.
It's the first time ever anybody said they liked my voice.
We'll just start. John will come up in a minute and we'll embarrass him appropriately for that. And then, but I wanted to start off, this is our chance for a little bit of Q&A. And I'm going to start us off while you guys maybe think of what you want to do and what you want to ask. And I would also point out that we have a tradition with the Rutgers Climate Symposium that we have we elevate our students, undergraduates and graduate students to ask. They get first choice, first run at asking questions, right? So don't be shy. If you have a question and you fall in those two categories, we really want you to come up. We have some folks running around. Oliver's over there with a microphone. All of you are way too young to remember, I don't even, okay, never mind. Huh? Oh, and Katie's on the other side. So they'll bring things around. You can raise your hand, but while you're thinking about that, here is John. Hi. I'm gonna sort of set things up and ask a couple bigger questions. We gave them these questions ahead of time so they could think about them a little bit. But I find this particular question very interesting because I've been asked this myself a couple of times, and it's an interesting question to sort of address. And that's, for each of you, is there a moment really that served as sort of an unexpected or hopeful catalyzing moment, either in terms of your own research or the interactions or the things that you choose to invest in that kind of brought you to where you are now related maybe to climate change and the things that you're experiencing? So if I'll just let you guys decide who would like to go first.
Yeah, you guys are still thinking. So I love this question. And I think it was April 22, we were invited to go show the waves at Jeanette's Pier near Coastal Studies Institute, where they were announcing the finalists for the Waves to Water Prize. Does anyone know about that competition? It was a portable, they were the National Energy Lab, National Renewable Energy Lab was sponsoring this project. And it was like a $3 million prize. And it was for a portable desalination unit that you can set up anywhere and pack anywhere. And I think it had a requirement for how much fresh water it would produce. And it had to be powered by waves. And we were invited, obviously, because John McCord was very involved in it. And we got to meet the finalists, talk to them. I got to bring my daughter and my niece who helped us set up the installation. And it was so inspiring. And the winner, Aneka Snowflake, can produce 7,000 liters of fresh water in a week, just with the power of waves. And very little maintenance, and anyone can set it up. It doesn't require maintenance, very much maintenance. And being able to talk, having access to that competition as a non-scientist and be able to talk to those innovators, it was like, we're going to be okay. These guys are brilliant. And that my daughter and my niece got to talk to those scientists, the next generation. It was truly inspiring and encouraging.
And I think it's really easy to focus on the doom and gloom, and it's essential to keep those thoughts in mind. But there's a journal I like called Yes. It's a journal of positive futures. And just knowing that there are people, in Eastern North Carolina or the middle of Wisconsin who are working on this and working on solving it and connecting the networks, the grassroots, tells us that there is hope and that there can be a positive outcome. But we do need to know the information.
Go ahead.
Well, I guess from my end, bit of positivity was leading into the Paris Agreement in 2015 and a campaign in the Caribbean called 1.5 to Stay Alive, and getting a lot of musicians and artists coming together to be able to speak to what their future looks like in a changing climate. And they came up with this wonderful campaign that went out to the point that we had students in schools singing the song while walking in the streets. And, that meant that, there was a recognition of the change, but there was also a positive feeling behind it that, we can make that change and we can all be resilient in the face of climate change.
Is this thing on? Okay, yeah. So one moment that I found really positive was actually this past summer. I went to a Clivar workshop in the North Adriatic Sea in Trieste, which is about an hour and a half's train ride from Venice. As somebody who studies sea level, I couldn't not make the pilgrimage to Venice, which is sort of the poster child of places where this aqua alta, as they call it, comes in. And the St. Mark's Square is notoriously filled with 1 to 2 feet of water during these aqua alta events. And as you mentioned, you have to experience these things, right? So for me, as somebody who sits behind a keyboard all day and does numerical modeling, this was my sort of immersive experience in going to it. And I honestly didn't know how I was going to feel emotionally through this. And when I arrived in Venice, I did some of the touristy things, and I started to look. I took a gondola ride through the canals of Venice, and I could see finally with my own eyes the things I've seen in the photographs and in the documentaries of the fragility of this civilization, basically, that's built on top of the water here. And I looked up to the guy who was rowing me, and I said, "How is the flooding?" And he said to me, "It's so much better now." And I'm like, "Well, what do you mean?" He said, "Well, within the last 5 years, they've built these giant seawalls that lead into the bay where Venice is located. It's a barrier island that separates Venice from the rest of the Adriatic Sea. And when they predict one of these aqua alta events, the technology saves them. These barriers go up and it saves them." And he says that since this has been put in at Venice, they don't experience the floods anymore. And he's so much happier as he thrives off the tourism, right? So, you could just see the smile come across his face, and telling me and the pride that he had that they found a solution, at least to this. So, we talk about technology transfer and times, and, to me, this was a hope of something that was pretty quick that came through. And that's what gives me a little bit of hope, this experience I had.
Thank you. Ben, do you want to chime in?
Yeah, and I can see myself on the screen, and my partner says I have a big head, but this is kind of out of control. Very inspiring answers. I'll give just 2 brief reflections. The first is that my interest in kind of this field even began when I was an undergrad student, and I went to a very small Jesuit university called John Carroll University, and it was there that they really emphasized service. So going to homeless shelters, helping others, and and learning about climate change and energy. I think we often forget that it's not just about technology, it is about just helping serve the community. And I kind of kept that little focus on service with me. And then more accurately to your question, I was reminded of a woman I met in Nepal. So I did some work on energy access and poverty around the world, including Southeast Asia and South Asia and Sub-Saharan Africa. And I remember I was working for the National University of Singapore, had flown in, got upgraded to first class, living the life, having great food, got a 5-star hotel, and then you go into the field, and we actually met a woman in a village who broke down in tears because she was so happy she owned a light bulb. Like when we asked her what the best thing you've ever had, she's like, I'm able to hold the sun in my hand. And it was that simple. Something as incremental to us as a light bulb was her most prized possession, and she was so proud about it. And it just made me think about how much we take for granted and how much we maybe don't need, and how much people can really benefit improved energy security and energy access in ways that we don't even conceive because we're so used to abundance.
Thank you. Those were fantastic stories, and I feel like most of us have those moments, honestly. And what was that moment, or what were the moments that sort of changed maybe your trajectory of research or the way you view your research? So thank you for that. Okay, so now we're going to engage in something that I engage in from time to time, usually when I'm taking a walk at the end of a long day. And I was like, what if I had the ear of my university president or the dean or even my department chair, and I could just talk to him like a normal human, and we weren't, and I could just say, this really matters. Like, this is the way I want to talk to you, not necessarily a deferential conversation, but a real conversation. And another piece of that, and I think it inspires those sometimes, is this challenge that we've taken on. And for me, that challenge represents sort of a representation of or a outgrowth of the fact that you get to a point in your career, you're like, wow, I've learned a lot. I have a privileged position. People have invested a lot in me, and I have skills that I can bring to some of these problems. So where's my role? What am I supposed to do, right? Maybe that's geared by the fact you have kids and you're worried about their future as well. But if you guys had a chance to have that frank conversation with the president of a leading research university, so what would you tell them especially, related to climate? What would you say is like, you really have to invest in this. This is something that's important for our leading research universities to do. So if you kind of grapple with that question a little bit. It's an easy one, so.
All right, I'll take a first go. I guess what I would say first is people matter. How you relate to people, how you impart information to people, how you identify with people matter, and simple things work. It could be as simple as just having a frank conversation with a fisherman or a farmer, to understand what their challenges are, what solutions they have been putting in place, to then figure out, okay, what sort of science can help to build even stronger resilience in the systems that they're doing. I think sometimes we, as academics, we think that the conversation is at a very high level, and we need to go into years of research to try to bring solutions forward that the existing technology has to be superseded. And sometimes it's just having those simple, frank conversation to, just understand what their realities are that changes the direction in terms of the approach that you take at the end of the day.
I think what I'll add to that in terms of the people dimension is I think we need to find ways to humanize science. If I had the ear of the president of Rutgers or any leading institution right now, I would strongly ring the bell about public trust in science. And it's not just in the climate issue. You can see this around through all sorts of aspects of medicine and the COVID pandemic. The amount of foundational trust in what research is being done along all dimensions, whether it's the fundamental climate science, the energy transfer, the societal dimensions, the art, the societal trust has to be there for us to address the climate change. And I think at least from my experience of having given some public talks and interacting with people, is that we have a ways to go in getting everyone to have faith that in the research that we're doing and the validity of our intentions.
Go ahead, Lisa Beth. Yeah.
We did talk about this a lot as well, and it builds on what these gentlemen are saying, that, and you guys are setting up a really good model for this. I would ask them to set up a model that isn't just a flash model, but that has long-term lasting ability to gather all the people and do this transdisciplinary, cross-disciplinary, interdisciplinary collaborating. You do need the voices of everyone and giving people agency to do what you're asking them to do, and then support it with funding, of course, but look at different funding models. I think that's really important. And don't forget the humanities. I know it's in crisis right now, but it's an essential part of that narrative.
And just to add to that, I think, John, you had said one of your favorite classes was the 101 class. I think the Gen Ed 100 level classes are such a great opportunity to influence, and maybe not just influence, but like help the young generation to think differently. I feel like our education system is so behind in a lot of this stuff. And like I teach art, I'm emeritus. But my favorite class to teach, and I'm still teaching it as an adjunct like you are, is Environmental Art 100. And that my students, hopefully they're listening right now, come into that class. I've got nurses, engineers, mathematicians, all the non-art students, and it's perfect because they have no idea what's possible in the environmental art world. It's a huge movement right now, and people are doing incredible things, and nobody knows about it. And this is a chance for us to teach the young people how to innovate, how to cross-discipline, work in cross-disciplinary ways. And if it's required, like your minor, if it's required of all the students, I think we're going to get those Ben's transitions even faster.
Ben, do you want to chime in?
Yeah, I'll try to be brief. I mean, I agree with everything that's been said so far. Easy for me to go last, especially the focus on the arts and humanities, which tends to be kind of afterthoughts, right? Even social scientists often can view themselves as superior to the lowly arts and humanities people. And I say this having 2 degrees in the arts and humanities, a BA in philosophy and an MA in communication studies. I think for me, I think about the 3 things universities do, right? Teaching, service, and research. I think teaching-wise, scholarships on sustainability and climate make a difference. Curricula, certificates, programs, all of that really matter, like having a school of sustainability or a school of climate change or a master's degree or a bachelor's in climate studies or climate policy. In terms of service, I think doing a lot more in the community, having a good campus climate plan, divesting from fossil fuels in your pension, helping protect frontline communities or communities of color, or even we have a campus climate lab here on BU where we put $150K a year into on-campus projects to promote sustainability, food waste reduction, looking at medical waste. We even have one that's arts and humanities that uses indigenous artwork to spread messages about sustainability. And then finally, for research, was kind of hinted at earlier, organize it around challenges rather than disciplines or colleges. Say, we want to have a program around low-cost, just solar energy. And then teams will come around that themselves rather than it being all these disciplinary ways of doing tenure, promotion, and funding.
Great, thank you. Thank you all again. So I want to open it up to questions. If those of you might want to raise your hand if you have a question. We're going to defer to students first. You're student. We're all students, right? Don't be shy. Go ahead. He's coming to you, Oliver, behind you.
Thank you so much for that. Dr. Gray, this is more or less directed at you. but you spoke about going into communities and listening to their lived stories and working and orienting adaptation around that. You also spent a number of years at the Green Climate Fund. I'm curious how you sort of navigated that maybe inherent tension in controlling the framework, controlling the finances, while also listening and adapting communities the way they see it.
That's a very provocative question. I can tell you that sitting inside an entity like the Green Climate Fund, while it was lots of good work, was very challenging. Coming from a small island, there are not many of us in that organization, so not many with the lived experience. It's always a challenge fighting with persons from the finance background, many of them coming from MDBs, where there's a feeling like, they're trying to protect the money to ensure that the investment is solid. But then trying to get countries that are putting forward projects to, find a mechanism to be able to speak to the specialists who are reviewing to understand what is between the black and white. I used to encourage them, for instance, submitting a proposal, set up a conversation with the various specialists, even submitting, for instance, a 3 to 5 minute video presentation about what that project means for the country, where the impact is going to be, so that we can have a better appreciation for what's going on. Those are some of the challenges being in that space. But at the end of the day, when I see projects being approved, and I can see the impact once implementation starts, then it gives me that drive to do more, because obviously something is happening and we can make it happen. I mean, when I see, for instance, on this side of the world, the single LDC country on this side, which is Haiti, and knowing the challenges that they're going through, and seeing Haiti, for instance, now have 2 approved national projects, it makes me go, if Haiti can get 2 approved projects, then any country can get a project approved. So, it gives you that added drive to keep doing what you're doing.
Thank you. Another question? Jorge? Katie's coming back around to you.
I am from the humanities, so my question is not really a hostile one. But just somebody has to be the labor of devil's advocate here. So from Elizabeth and Kristine's presentation, but also the way the conversation is going, it's clear that we're looking at is the kind of communication in which we come out of it feeling that something has happened in my life, right? I go into an emergent experience that touches me in a way that nothing, or the majority of nothing, will be any more the same after coming out of the exhibition, or I engage in the conversations, such conversations in which I tell a story in a way that it is unique, and I listen to somebody's story in a way that it is unique. So something has happened in my life. But I'm also thinking the thing about something happening in my life is so immediate, seems to have that powerful instant. But I'm also listening that transdisciplinary research requires time, even more time than regular science, and even more time than regular art, just to use probably the wrong adjective. So I was wondering if, in terms of Ben, arts and humanities are important, but do they have a role in the acceleration of transitions, or more of the role has to do with intergenerational transitions? And I don't know in general how you feel about it, but probably it's one of the interesting questions, because as much as everybody have done advocacy for the arts and the humanities, and this is not a criticism to Ben, the impact of art in the humanities was not in that evaluation of the drivers of transition. So either it seems that we lack data on the impact of art of humanities, or we don't feel it necessary because there seems to be an agreement that art and humanities are very important. So in a way, we don't need the data. But I'm trying to think is we are in the column of the kind of things that accelerate the change, have an opportunity to accelerate the change, or we are more in the intergenerational transitions. Thank you.
I think that was to you, Ben.
Yeah, it was. I want to share my screen if that's okay. I see the arts and humanities as kind of fundamental, and I'll show you why in a moment. There's a colleague of mine called Daniel Sprang that mapped transdisciplinarity energy research, and it's really nice. It's open access. I hope you all look it up later. Here's the title, if you can see it. Transdisciplinary research reflecting the context. And here is this, sorry to make you dizzy, this beautiful graph there that really situates the arts and humanities as kind of at the top of the hierarchy, right? It's really about these deep questions about values and ethics and philosophy, about values and what we do. But it's also really important to things relating to norms and what we're capable of doing. So I would put kind of communication, persuasion, and marketing there as well, and even some elements of sociology. So I just like this. It kind of implies that there's no superior disciplines. They all interconnect. They all have different goals and they all answer different questions. But I think to get a holistic picture of a transition, we need them all. And I like that the arts and humanities are here in plentiful form.
Yeah, of course.
Also, I think maybe I gave you the wrong impression that everything is slow, because how many of you, just hands up, how many of you saw the video where they pulled the straw out of the turtle's nose? 3 years and nobody's using straws. And that's pretty incredible, and it's fast.
True. Alan, I know you want to, yes. So here's Oliver.
Hi, Alan Roebuck. Ben, we met earlier this year at Livermore. Hi, nice to see you. I have a question for you. These transitions you're talking about, many of them were not opposed by such a huge economic interest of the fossil fuel industry now. I mean, the biggest economic transition in the United States, I don't know if it was on your graphs, was the end of chattel slavery, where a huge economic system was changed, but now we're fighting again. You know, we do research, we do humanities, we do climate science, but if my congressman is a Republican, Chris Smith I live in Monmouth County, and he's vehemently against wind turbines. And when Ørsted backed out last week, he said, "Oh, that just proves that this is a terrible way to do it." And if he would run on a green campaign, the fossil fuel industry would pay somebody else to run against him in the primaries. And so, how do we push back against this huge economic interest? Did that happen in these other transitions?
To some degree. I mean, it also depends on how long you have history go back, right? So, I mean, by 1970s, Brazil had a sugarcane economy, which made ethanol really attractive. Political economy was behind it. So the flex fuel mandate was really supported by the incumbents. You have other transitions that break into the incumbents, like oil transitions in Kuwait. Well, that was a lot of multinational firms, right? Like Saudi Aramco and Gulf Western and ExxonMobil and all that. So it does kind of depend how far back you go. I think in terms of what we do about it, misinformation campaigns are actually rife. Our colleague Timmons Roberts at Brown has tracked misinformation campaigns in New England about offshore wind killing whales that seem to be very influential with people, even though they're completely false and debunked. So I guess one response is it's our job kind of to try to fight misinformation as best as we can. I think the other one is to highlight the winners and losers for these transitions. And sometimes the losers are so significant. I mean, I've seen cost-benefit ratios for energy efficiency that suggest every dollar you put in gives you $35 in benefits: health, resilience, avoided air pollution, jobs, and so forth. So it's switched the narrative. You can say this isn't about green sustainability, it's about jobs, economic welfare, skills, right? And becoming maybe a regional leader. If we make offshore wind here in New Jersey, maybe we do it next off the Carolinas, next down south, next in the Gulf of Mexico or Lake Erie or Lake Michigan. So I think it's kind of just flip the narrative back. There's so much to be gained from these low carbon transitions that, I think one of our studies looked at 4 low carbon transitions and 128 co-benefits. 128. So maybe just try to harness the power of those narratives.
Thank you. Yeah, one more question?
Hi, I'm an undergraduate student, and this question is specifically for Dr. Gray. And so I'm really interested in more of like the activism side and more of the social justice side. And I have kind of an innate passion for it. And I am working with other students from other universities. And we also want to use our privilege of being in a higher institution and just being able to go into have the privilege of being a student in general to have access to be an activist, because I think that's a privilege in itself. And so we want to, the idea is to use other local leaders showcasing and helping push local environmental racism movements or environmental racism that's going on in their area. Do you think that's the best way, or how do you think the best way students can use their platform to help like amplify other people's voices? Yeah.
Thanks. I don't think there's any right or wrong way to go about doing it. But I think what would be essential is to be willing to go into those spaces and listen. To have the message that you're planning to put forward, it needs to resonate with the audience that you're also trying to support. So, for me, it's like, if it's the Global South, for instance, I would say, take a few vacations here and there, go into some of these countries, walk and talk with the people on the street, not the ones in the office. So go into the fishing communities, go into the farming communities, go into the rural communities, have a chat with people to understand where they're coming from, what are their challenges, and see how that aligns with the type of messaging that you thought needed to bring to the fore. It will help you to tailor that message, but bring simplicity to the message as well. Because while we're in this audience, a lot of us understand the science or speak at a certain level. But if you're talking to the general public, you have to break that down to a level that everyone can understand. Something that will transcend regardless of who the message is going to. And, be consistent. There are a lot of young international groups for, especially academic students, whether it be a student movement within the university or even the young NGO community under the UNFCCC, for instance, where you can have that audience to be able to speak and relate with others and get that message out. So I'd say, just be prepared to listen, keep your message simple, and be consistent about the message that you're putting forward. Hope that helps.
Thank you. So I think we have one more question. Lily, go for it.
Oh, okay. I also had a written question from someone.
Hi, my name is Lily Young. I'm in the Environmental Sciences Department, and I'm teaching a seminar to graduate students right now. And the challenges that, as environmental science students, they come from all different backgrounds, as the panel. You're all from very different backgrounds. And much of the news, especially in the media, is very much doom and gloom, as was mentioned earlier. So the challenge for the students, I asked them, since they're from all different backgrounds, is to consider what in their lifetime they can do and anticipate as positive action that they can take. Because for us, we've gone through a huge transition over the last 15, 20, 30 years with regard to our attitude towards science. So I guess my question is to each of the panelists, since you're from all different areas, if you were a student today, what would you be looking to do, and what kind of decisions would you be making in your field that would be a positive outcome, not just this doom and gloom we got? Okay, what can you do to make it better in each of your fields if you were a student?
So I'm going to jump in because I got to go to a faculty meeting in 4 minutes. So I'm going to go first. Great question. Lots that you can do. I'll make it really simple. We've looked at carbon footprints, and the 3 immediate changes that you could make to almost half your personal carbon footprint: eat less meat, fly less, drive less. Or better yet, become a vegetarian, give up flying, give up your car. Those are 3 immediate things that you can do tomorrow that have an immediate impact on the climate. And then if you get your family, your community, your college, et cetera, to do those things too, they can really make a difference and even save you money in some context. So difficult to do, but at least that's what some of the science is telling us.
Okay, and I'll just also thank you, Ben, because if you have to run now to the faculty meeting, although I don't know why you would leave us for a faculty meeting, that's a strange decision. But we really appreciate you being here and participating. So when you have to jump out, please feel free, but thank you very much. I want to give everybody else a chance to answer that question. Yeah. Go ahead.
I can go briefly. So the elephant in the room is 7 billion people. I mean, that's the population of the Earth, and that's really what's driving this. But we could think of each of that as 7 billion carbon footprints, but we could also think of that as 7 billion minds, right? So, you know, when I wish Ben were still here, because one comment I've been meaning to ask him is that, you know, with that brain power, I think about running computer models. You know, you want to run the model faster, you get more CPUs, you get more computers to run. So, you know, are these transitions going to be sped up by the fact that there's just more humans here? We've got more brains on the problem. And to answer your question, Lily, I think one way that I would think about in retrospect of how I could influence my field is to think about ways to get those brains engaged on the problem. Where are the barriers? What are some ways that we can increase access to get students who want to work on these problems into graduate school and beyond? How can we increase the value of graduate degrees? How can we expand the scope of what we would consider classical master's or PhD worthy projects to include things that are more application driven? There's still plenty of things we need to do on the fundamental science, but we have to start blending in as we talked about. And we see this with these national plans. You know, you have to plan, but you also have to act too. So we have to take that approach in how we handle graduate degrees and education as well.
It's sort of both advice to students and to educators. One of the final projects I give my students, I'm so sorry. At the end of the semester, my students don't realize this, but they do now, is they have to think of how in their field, so I have all these non-majors, how they can collaborate with an environmental artist to move their field forward in a more positive environmental way. So that could be mathematics, that could be nursing, that could be social work. And it's really hard for them. And what I've noticed is that it really helps those freshmen to imagine with a mentor sort of helping them brainstorm, because they're like, I don't know, I'm a nurse, I do nurse stuff. But if you have someone or multiple people in different disciplines to sit down with that student and brainstorm, well, this is how a nurse could implement these pro-environmental behaviors or technologies, or possibly even innovate. If they think about that sooner, earlier, right at the beginning of their education, every class they take after that, that idea of thinking outside of the box and how they can transform their life, not in just, okay, I mean, I also approve of the vegan direction, but beyond that, like, how can I shape my life in a way that's going to make a positive impact professionally too?
I also remind them that they're part of a whole. Their gestures don't have to be tremendous. You're not going to be the next YouTube star necessarily. But I love that Margaret Mead quote about if you want to see if one person can make a difference, ask a mosquito.
Yeah, I mean, that's a challenging one for me personally, because my experience, it's very much different from undergraduates in United States, for instance. So I would say, if I was an undergrad again, be willing to speak more about the little things that I do. Sometimes those little things add up, and we don't see it because we think it's just a part of what we're doing, or the little promise that we made in ourselves to do something. But the more we talk about it, it's the more that we can get a movement going around something positive that others are also doing that we just didn't recognize. You know, and I'd say from the perspective of a lecturer in that space, is to create that space for undergraduates to have a chance to speak about what they're doing, how they're doing it, and how they think that little change could potentially influence bigger changes down the line if more persons were doing it. And that may just be able to generate that sort of momentum going forward, and also help them to figure the pathway that they want to end up at the end of the undergraduate program.
Okay, so I think with that, we're going to wrap up. And I want to thank all of you one more time for being amenable to all these questions, and also to taking the time to be here today. So thank you very, very much. Okay. Oh, okay, right. Okay, a couple final housekeeping things. Number one is that we're going to raffle off some of the waves. That's right. That's right.
The numbers, and I'm going to get them back.
So you want me to hear you, whatever. How many do we have to give out? Oh, there's a few more. All right, we'll just start. It's completely blind. I have no idea what I'm doing. Okay, so the first person is 258-7601. Woohoo, right back there. Come on up and get your wave, catch a wave. Next one up is 258-7584. Anyone? They left, so that one goes over here. They get nothing, okay? Okay, 258-7576. 7576? Yeah, all right. You get away. Huh? Oh, yeah. So when you come up to get your wave, just, I believe you. We would love for you guys to stay up here, take a group picture so we can add to their collection. Next one is 7650. 7650. They get nothing. 7626. Everybody left. Okay, fine. 7628. All right. I'm sure there's a phone in here. 7620. 7620. 7622. All right. We don't know. Gotta be somewhere. 7589. Oh, all right. 7564. Yay, right there. Okay. How many we got left? Okay, we got one coming up. So 4 more. 7559. Yeah. Seven, 5, 4, 4. 4, 4. 7, 6, 1, 3. 7, 6, 1, 3. Yeah? Yeah? Okay. Okay, 2 more. 7, 6, 0, 3. Oops. 0, 3, 7, 6, 0, 3. 7, 6, 3, 7. Yeah, all right. There's one of our volunteers on top of it. That's great. Okay, and this is the last one. 7, 5, 7, 3. All right, Mike, all right. One of my crew. Okay, so you guys hang out here. We're going to take a picture in a minute, but I also want to do a little bit of housekeeping things. We have lunch. Where's lunch? It's in the back. So you get some lunch and you'll bring it to your table. Please enjoy lunch. And then at the end of lunch, we'll make an announcement. We want the people who, when we break, to go up for the poster session. So the poster session happens after this. It's in 2 rooms upstairs. The division on who's in each room is solely by last name, not by theme or anything. So please check out both of those. Take some time. This is from our graduate students and undergraduates and postdocs, or for you to learn a little bit more about what we're doing at Rutgers and beyond. But we will break up and invite our poster presenters to leave a little early from lunch so they can get up there and be ready for all you guys to come up and see everything. So I want to take one final moment to, yes. Oh, right. That's right. That's what I was supposed to do. So if you are doing a poster session, you get first dibs at going over and getting lunch so that you can eat calmly, finish, and then go up and be ready, right? The final thing I want to say is a big, big thank you to Marjorie and Oliver and Matt and all our volunteers. This is a tremendous amount of work. It's a tremendous amount of work to pull this off, and they do a fantastic job every year. So thank you, thank you, thank you. Oh, okay.
Hi, I'm Mike Allen. I'm a researcher in the Department of Ecology at Rutgers.
Hey everyone, my name is Vincent Liu. I'm currently a master's student at Blaustein, Master's of Public Informatics, and I'm a volunteer for today.
Hi, I'm Ashlyn. I work at Blaustein in the EAC group. Woo.
Hi, my name is Journey. I am a graduate student in Earth and Planetary Science.
My name's Sophia, and I'm an undergrad in environmental science at Temple.
My name is Mildred Lopez. I'm originally from Lima, Peru, and I'm in the Spanish and Portuguese PhD. Thank you.
My name's Teresa Puzo. I work at Rider University, but I used to be a student at Rutgers.
My name's Carrie Sendall. I employ Therese at Rider University, and I'm a professor there in the biology department.
Hi, my name is Jordan. I'm a senior here at Rutgers. I'm with the Office of Climate Action here at Rutgers. I'm an intern, and yeah, woo, go Rutgers.
Hi, I'm Ganesh. I'm a postdoc at Princeton University.
Thank you for that, Marjorie. You get a good sense of all the folks who show up for this, so it's fantastic. Okay, so let's eat and enjoy some time to talk to each other, and please stick around for the poster session. Thank you again.